Welcome to Lesson 6, Manage Azure VMs, where we explore how to manage infrastructure deployments in Azure. We discuss how to create a VM from the Azure Marketplace and how to configure VM networking and disk storage. We also talk about automated VM deployment from templates and disk images. We finish by discussing availability of VMs through availability sets and VM scale sets. There are many ways to create a VM in Azure, but perhaps the most common is through the Azure Marketplace. It has literally hundreds of VM images you can choose from. You can choose Windows or Linux as a base OS. You can also choose the OS plus some workload software. So for example, if you wanted SQL Server running on a Windows server, you could pick that from the Marketplace as well, and there are various versions of Windows Server running various versions of SQL Server. There are several choices you make during creation. One, of course, is your operating system. Windows 2012 is the earliest Windows version that you can install from the Marketplace. Linux has several distributions as well, Red Hat, Ubuntu, and there are others. So you need to know basically what operating system you want to run to begin with. Also the size of the VM. This is an important choice you'll make. How many CPU cores you want, how much memory or RAM, what's the maximum number of data disks you need to deploy with the VM, what kind of I/O performance might you need. You'll have two choices for disk performance, standard or premium. Standard is a magnetic drive, premium is a solid state drive. And then you also might decide about administration ports, let's say for RDP or SSH. You could also leave that turned off, it's your choice. Most of the settings that you make at VM creation time can be changed after the VM is created. A couple of words about VM sizes. So VM sizes come in what are called families. You see some D series VMs here. What to notice when you look at VM sizes: how many vCPUs, how much RAM, how many gigabytes of RAM, and then max data disk. So data disk columns lists the maximum numbers that can be attached to that particular VM. Also max I/O per second, so that's about your I/O performance. All VMs have some kind of temp storage. The page file goes there. You can put temporary files there too, but don't store anything there you want to keep, because at each reboot, that storage account is reinitialized. Premium disk supported here means that you're allowed to attach SSD drives to that particular VM configuration. Let me say a few more things about VM families. You don't have to memorize all the families for your exam, but you should just have a general idea of the kinds of VMs you can set up. General purpose VMs are good for often low to medium sized web servers, maybe database servers. So those include a lot of things in the D family, the D series, sometimes the B series. The compute optimized have higher CPU to memory ratios. The memory optimized have higher memory to CPU ratios. So it kind of depends on whether if you know you need a lot of memory to do some processing, then you might want a memory optimized machine as opposed to a compute optimized. The configurations that specifically support graphics rendering and graphics processing, the GPU family types, most of those are the N series. And then might be good to just keep in mind too that if cost is no option, if you want the highest performance, the most amount of vCores, the most amount of RAM, the most amount of disks that you can attach, the H series is where you'd want to go, H for high performance. Let me show you in the portal what it's like to set up a VM. Many choices you make. It's one of the more complex things you do in Azure, setting up a VM. I'm going to use the resource group I have, E*G. Give this VM a name. Put it in East US as well. I'm going to choose Windows 20 Server 19 Data Center for my image. And here's the size. This is just a default size. I can change this if I like. I'm going to leave it as a default for now. I need to specify the login account for this. This will be the Windows login, like the administrator on that OS. Must be a complex password. I can open a port now. I can leave the port closed and open it later. I can do other options as well. I'm going to leave port 3389 open for RDP access. Next, we go to disks. So you will always have an OS disk. The OS disk can be SSD, premium or standard for different price points. You could also choose a magnetic drive, HDD, if you want for your OS disk. Your data will be encrypted on that disk automatically. If you want to add data disks, you can add them now. You can also add them later. I'll do that later. Under networking, all VMs have to exist on what's called a virtual network. We'll talk about virtual networks in the next lesson. I already have a VNet. Here's East VNet. I'm going to put my VM on East VNet. It has to also live on a subnet on that VNet, and Azure has made that choice for me as well. I'll leave that. Since I have RDP port 3389 open, I probably want a public IP for that VM so I can connect to it from outside of Azure. The marketplace is going to create a public IP address for me. I'll just take the default. So I didn't make any changes on this page. Under management, boot diagnostics are visible by default. This is useful if the VM won't boot and you want to try to find out what's wrong with it, because if you can't boot it, you can't get to it, can't log on to it until it's booted. I'll leave these other options as they are. They can all be changed later. We'll also talk about extensions later in this lesson. So I'm going to review and create. When this is finished, we'll talk about a few of the options for VMs. Okay, my VM is created. I'm looking at the overview blade of it now. In the next part of this lesson, we'll talk about several of the blades here that include configuration you might want to change. But let me point out one thing now, which is the connect blade. I added a public IP address for my VM when it was created, and here it is. This is the IP address that's used to connect to that VM. And since I opened port 3389, I can access an RDP file here. And the portal will allow me then to use that RDP file to access that public IP address to log onto that VM from outside of Azure. We'll talk about other ways you can control accessing VMs in a little bit more secure way than using a public IP address. But this is a nice way to quickly be able to get onto a VM and configure it if you need to. One of your exam objectives is moving a VM from one resource group to another. There didn't used to be a good way to do this. The recommendation or the requirement was to tear down the VM, save the disks, move the disks somewhere else, recreate a new VM in the new location. There's a resource mover in Azure now that you can use to help you move resources. You can either move a resource across subscriptions or to a different resource group. Realize if you change subscription, that could affect your billing, of course. If you change a resource group, it might also affect how you access that VM. For example, RBAC. If RBAC was set at the resource group level and you move the VM to a different resource group, then who can control that VM might change. Just so long as you're aware of that. You can also use Azure Resource Mover to move resources across regions. So that's moving things to different data centers, right? Azure VMs, VNets, and SQL are supported, as well as other services. Some services are not. For example, Azure Storage is not supported as a move across regions. The process is shown at the bottom in this diagram, and Azure does most of the heavy lifting, which is really nice. You select the resources you want to move. It will validate the dependencies on those resources to see if other resources might have to move as well. Azure then generates a resource manager template, something we'll talk about later in this lesson, that can be used to deploy resources. And then it deploys that template and moves the resources or creates resources as needed in the new location. When it's finished, you can commit the move or discard it, roll it back if you decide you don't want to. You also might then do some cleanup in the original location by removing some source resources. Let me show you where you find that in the Azure portal. Just go look for the resource mover. And you can move resources to another subscription or to another resource group or to another region. So moving across resource groups, you choose the source. For example, if I wanted to move my VM, it's an East RG, and I want to move it to a new resource group. Pick the resources I want to move. Azure will check for dependencies and figure out whether this can be moved or not. The validation succeeded. I'll go to the next, and I can review my choices, check this, and move the resources if desired. So the Azure Resource Mover has certainly cleaned up, made it much easier to be able to move resources across either subscriptions, resource groups, or sometimes even regions within Azure. Let's talk about some of the things you might set up for a VM after it's been created. The first is its networking configuration. All VMs have a private IP address. It's assigned automatically to the VM when it boots from the virtual network where the VM is deployed. Some VMs have more than one private IP address. It depends on how many network interfaces that VM has. A VM has a minimum of 2 NICs that are supported. Others may be supported in addition depending on the size of the VM. Some VMs may have a public IP address assigned. This is your choice whether you want to assign a public IP address if you want that VM visible to the internet. You also might configure network security. This is controlled through a resource called a network security group. We will cover all these details of networking in lesson 7, but let me show you in the portal where you see this information for VMs. Here's my VM, VM1. On the networking blade, you can see a summary of the configuration. I have one network interface. That network interface has been assigned this private IP address. I happen to have a public IP address assigned to this VM as well. Here's the virtual network and subnet. And here's a summary of the network security group, which indicates inbound port rules and outbound rules. Again, we'll cover details of this when we talk about virtual networks in lesson 7. Another thing you might configure for VMs is extra storage. So a VM would naturally have an OS disk, which is running the operating system, but you can also add data disks to the VM. The number of data disks depends on the VM size. Minimum is 2 and the maximum is 64 for some of the larger VMs. This table here summarizes features of different types of disks. So HDD is a magnetic drive, a hard disk drive. The others, SSDs, are solid state drives. You make a choice when you create a data disk what type you want it to be. And you can see some information about its maximum capacities. I wouldn't memorize necessarily all the stuff you see on this slide, but know that there are different types. SSD is faster and costs more. There's different kinds of SSD, including UltraDisk, which has a maximum storage capacity of 64 terabytes. The other drives max out at 32 terabytes. Let me show you how to add a VM disk. So on my VM under disks, you can see my OS disk here, along with its size and information. I can easily add a new disk just by filling out this information. I need a logical unit number, a disk name, what type you want it to be, premium SSD, standard SSD or HDD, and then a size. I'll talk about encryption momentarily. When you're done here, need a disk 2. I'll save. You must click Save here to attach this disk to the VM. If this were a Windows VM, you would then log on, go to say Disk Manager, format the drive, give it a drive letter, and then it would be accessible to the operating system. Let's also talk about disk encryption. You should know that all data in Azure is encrypted at rest using what's called server-side encryption, or SSE. You can't even turn this off. Azure manages the encryption keys, although you can bring your own keys if you like. And SSE is transparent to the VM itself. So the VM doesn't realize the data is encrypted. It's encrypted as it's written to the physical disk in the Azure Data Center, and it's decrypted as it's read before the OS sees it. Another option for disk encryption is what's called Azure Disk Encryption, ADE. So Azure Disk Encryption is OS-aware encryption. It integrates with something on the operating system. So for Windows, that would be BitLocker. For Linux, dmcrypt. In those cases, if you need your OS to manage its own encryption, you can use Azure Disk Encryption. Note that you don't turn off SSE, you just additionally use ADE, and there's a doubly encrypted data. If you use customer managed keys, then you must put them in what's called an Azure Key Vault. An Azure Key Vault is a place where you can store secrets, passwords, keys, things like that that you need to secure. And Azure requires it for customer managed keys for VM disk encryption. Let me show you how to manage disk encryption for a VM. I'm still on my disks blade. I'll go to additional settings. And so I can turn on Azure Disk Encryption here, choosing OS disk or OS and data disks. Notice then I must select a key vault. I have one created. I can pick a key. Let me show you just a little bit about this key vault. So my key vault in Azure has a key in it. It's just a key I created in here. It could be the encryption key for a particular VM. I also need to set access policies. So this is a good thing to remember for your exam as well. About key vaults, they're normally accessed through something like RBAC or some access policies you establish. But it is also possible to provide special access for Azure services. And I've checked all three of these boxes so that Azure VMs, when they're being deployed, can access a key vault, let's say to get access to an admin password or perhaps an encryption key. The resource manager can also use them for template deployments, which we'll talk about later in this lesson. And then the last one here is most important for our use now, which is Azure Disk Encryption is allowed to access this key vault to get access to the key to encrypt and decrypt data. So I'm not making any changes there. I just want to go back to my disk settings. I've chosen my key vault. I need to pick a key. There it is. pick the version of the key, in this case just the latest version of the key, and I save this, and it would encrypt the OS disk for my VM. The last item I want to talk about for VM configuration is what's called extensions. So a VM extension is a service which runs on a VM and enables control from outside the VM. This can be good for post-deployment configuration, it can be good for automation, sometimes for Azure services just accessing logs or things like that on the VM from outside. Some examples of VM extensions that Microsoft has written: there's one that assists in Azure performing backups of your VM. There's another that can collect system logs. There's two of the common extensions I want to cover. One is called a custom script extension. The other is called PowerShell Desired State Configuration. So custom script extension is just a way that you can, from Azure or outside of the VM, download and execute a script on that VM, and then report the results back to Azure. You could use it to turn on a Windows feature, you could use it to install software, perhaps clean up temp drives. Anything that you can write in a script, let's say a PowerShell script, you could download and execute as a custom script extension. In fact, these are often written in PowerShell just because PowerShell is a nice way to control your Windows box. And when you write that script, you specify it. At runtime, you place it in your Azure storage account, and the VM will download the script, it'll run, and the report comes back to Azure. Let me show you how to set that up in the portal. So back on VM 1, go to Extensions and Add. So you'll see some third-party extensions here as well. I want to look for the custom script extension. I'll select it. Now I need to specify a script file. If I browse here, I get shown my storage accounts. I have a storage account, I have a scripts container, and maybe here is my PowerShell script. I select it. If I need options or for arguments, I can specify those there, review and create, and it'll push that script to the VM. So this can be a nice way to cause some configuration to happen from outside the VM, and it's fairly easy to set up and execute. The other kind of extension I want to discuss is called Desired State Configuration. This downloads and executes a special PowerShell file to a Windows DSC service. So the DSC service is a service that's running on Windows, and it knows how to interpret these PowerShell files and determine the state of the machine. So the file that you create in PowerShell specifies what's called the desired state. And it could include things like what Windows features should be installed, what services should be running or not running, what user and group accounts should exist, certain files that should exist or registry keys. Here's an example of a DSC file. The important things here are, it is Windows feature that this DSC file is concerned about, and the name of the feature is web server, so you can probably guess that's IIS. And the ensure present means make sure that IIS is installed on this particular machine. So if you download this DSC file, the Windows DSC service on the local machine will look at this file and determine whether the machine itself is in compliance. And the DSC service can do three things. It can just report the state back if you just want to audit and know. It can correct the state. In other words, if IIS is not installed, it starts the install process. It can also correct and then monitor. So monitor allows you to set a period of time when the configuration file should be reapplied, and that way you can maintain the desired state of a VM. Let me show you how to do one of those in the portal as well. The setup is very similar to what we did for custom script. On the extensions blade, I add the PowerShell desired state. I'll select that. Now, there are some rules about desired state configuration files. It needs to be a PowerShell script in the syntax that I showed you, but it has to be stored in a zip file. So you need to take that PowerShell script that contains the DSC, put it in a zip, upload the zip to your storage account. And then you specify a few other things here, like the name of the module, the name of the function, any parameters or arguments you want to pass in. You also have to be concerned about versions of PowerShell. Oh, that's supposed to be a backslash. Let's change that. Review and create. And this will download the DSC file and then contact the DSC service, reporting back the results when it's finished. Let's talk about some ways you can automate VM deployment. The first is ARM templates. So the Azure Resource Manager, or ARM, is what I think of as the engine of Azure. It's behind the scenes handling all the requests that come in for access to resources. It also is used to deploy new resources. So an ARM template is a file you can submit to the Azure Resource Manager that describes a set of resources that you want to create or update. This enables you to script your setup of resources. This is called infrastructure as code because the file is considered code that you can save somewhere, you can check into a repository, you can version. But when you use this code to deploy, it creates infrastructure. This is great for being able to duplicate an environment in Azure. If you have a set of resources that need to be created for each new department, for each new customer, then having these scripts means that you can easily deploy these resources without having to do it manually through the portal, with the potential of making mistakes. It is possible with these script files as well to pass in data as you deploy. So parameters and variables are used to customize the deployment, making resource names different for each time you run the script. You can generate these from the Azure portal, and I'll show you how to do that in a moment. You can also create a library of ARM templates that helps you just manage your templates over time. There are many quick start templates or templates ready and available for your use, and I'll show you an example of that in a moment. Before I jump to the portal, let's look at an example ARM template. You should have a rough idea of the syntax of an ARM template. You don't have to create one on your exam, but you might have to recognize one and identify certain parts. So the required sections are in lines 2, 3, and 11. Lines 2 and 3 represent the schema and content version, which just says what kind of syntax is expected in this file. Line 11 is required to be there. It's the resources section, and it describes the resource that you want to create or update. In this particular example, you can see a very simple single resource template, and what does it create? A public IP address. So the syntax for this file is a JSON syntax, JSON, and JSON syntax specifies that you have a key name, followed by a colon, followed by the value for that, and then a comma, and then the next key value pair. So you can represent all the properties of a particular IP address as you create it. For example, you can see this one is location East US, so that specifies East US region. The SKU is standard. There's the IP address of a specific IP address that's being assigned to this. Even under DNS settings, there's a fully qualified domain name. You could use the portal and create this as well, but submitting this ARM template to the Azure Resource Manager means that Azure can do that for you. So again, required sections are schema, content version, and resources. The resources is the most interesting part because it just describes one or more resources that will be created. Let me show you how to generate one of these in the portal. I'm looking here at a storage account. You can scroll down near the bottom of blades on most any resource in Azure and you'll find Export Template. This blade here will cause Azure to generate a template file which you can use. So we can already recognize down here the first resource listed in this is a storage account with its parameters. There's another resource down here of blob services. That's the blob service you can put inside a storage account. There's file services, and you'll find the other two down there as well, queue and table. So this template file I could save to a library. It says here once you save, the template will be found under templates. I'll show you that. So my template is saved. I can find it under templates. And hasn't showed up. Let's try refresh. And there it is. Create storage. Here's my template. I can edit that template. Change names of it if I want to. I can also deploy this template. So you can take any ARM template and deploy it. You get taken to this custom deployment page and you fill in the parameters. These are the things that might be different for each deployment. And you can then create a new storage account. I'll change the name. You have to agree, and then purchase just means you're going to pay for this resource once it's set up. And when it's finished, I'll have a new storage account. So take some of the time out of doing things manually and cuts down on errors. Let me also show you about Quick Start templates. You can just open a web browser and search for Azure Quick Start templates. You'll find this link from the azure.microsoft.com site. So there are over 1,000 templates that have been contributed by the community. You can look for one. I'm going to look for simple Windows VM. There's deploy a simple Windows VM. You can read about this template here or just click the deploy to Azure. If you're in the same browser window and logged in, it'll just take you right back to your Azure subscription at this page where you can deploy this new resource. So these are all the parameters that are needed by that particular template. If you wanted to, you could edit this template from here. You could edit parameters for it. Once you edit it, if you like this template, you can save it to your template library. So Quick Start templates are a nice way to be able to manage more complicated resources that you might not have set up before, but that you want deployed in Azure. Next, let's talk about combining desired state configuration with Azure Resource Manager. So you can use ARM templates, creating a special kind of ARM template that deploys a VM extension, DSC. So what you do is in the resources section for your template, you have a resource whose type is virtual machines / extensions. So that's the specific name of the resource you need to deploy. In this case, it's DSC. And you see further down here in the properties, the type is set to DSC. There's a handler version. And then another important thing in here too would be specifying where the script is. It occurs later in the file, so I'll show you another snippet from this file. Later in this same ARM template, you would find a settings section, and you specify the URL to an Azure storage account where you have uploaded that zip file. Remember, the DSC requires a zip file that contains a PowerShell script. You name the script with the script property. You name the function in the script. If you need to specify any tokens to access the blob storage, you can do that too. But deploying this DSC file can cause the script that's listed in this iisinstall.ps1 file to be executed on a particular VM. We can use the same technique for custom script extension. So here's an example script for that. Again, we use the type of extensions. So that particular resource type has to be deployed. Under properties, you see the type is custom script extension in this case. And then the protected settings specify the information about where to find the script file. The properties are different than we saw for DSC, but they are ones that make sense. You have to name your storage account, indicate your storage account key for access by ARM as it's accessing your script. In the file URIs, you would name the name of the script location so that you could, or Azure Resource Manager could find and execute that script. So both of these can be nice ways to customize VMs after deployment, even using the other techniques we discussed, PowerShell, DSC, and custom script. The last topic I want to cover in this section is on virtual disk templates. So a virtual disk template is just a disk that can be used to create a new VM. VHD templates are often called images, and they might be used as a VM image to deploy a new VM. You can create them in the portal with what's called a capture command, and I'll show you that in a moment. It places the image in a place in the portal called the Azure Compute Gallery. When you capture a VM, you choose the type of image you want to create. A generalized VM would be similar to taking a Windows VM and running sysprep on it, where it strips all the information out of the VM and makes sort of a shell or a template for a VM. The first time you boot that VM, you have to finish the configuration, specify the admin information, the machine host name, and so forth. The other kind of VM you can create in a compute gallery is a specialized VM. That one does not have admin and machine names information stripped out of it. It's basically ready to boot. This is a great idea if you need VMs, several VMs that are alike, but you need custom software on them. So you might first set up the VM in the portal, customize it, log on and customize it, add the software you need, and then capture the VM image. And then you can create as many VMs as you want from the captured image. Let me show you how that works. So I'm going to go to my VM, VM1. You'll see on the overview blade there's a capture. So when you create an image, you specify an image gallery. I need to create a gallery. Specify your operating system state, generalized or specialized. I'll pick specialized. You need to create what's called a VM image definition. It just contains information about the VM that's in the gallery. Its publisher, operating system, version, and things like that. You also need a version number, so you have to version your images. You can set lifetime if you want. That's basically it. You can review and create. And when this is finished, I'll have an image in my gallery that I could use to deploy a new VM. Okay, my capture completed. Let me show you the compute gallery. There's gallery 1. And I can scroll down on the overview blade and see there's my image def for VN1. I can create a VM from this. I could create a VM scale set from this, or add a new version of that VM. To finish out this lesson, let's talk about high availability for VMs. One way you can do that in Azure is through what are called availability sets and availability zones. What this does is really places your VMs on different hardware racks and on different Hyper-V hosts. And the effect of that is it can protect you from hardware outages and software outages. With availability sets, there are two terms you should be aware of. One is called a fault domain. So a fault domain is where VMs are deployed to different server racks, essentially. And so a server rack, each server rack in an Azure data center has its own power cord and has its own network connection. So if the power or network fail to a given rack, it takes out all VMs or infrastructure that's on that rack. And so by deploying VMs on different fault domains, you increase the availability of those VMs as a whole. So in this picture, you can see 3 fault domains, FD0, 1, and 2. And if you have VMs deployed to each of those fault domains, if one rack goes out, then you still have some of your solution running. The default number of fault domains is 2, and the max is 3. An update domain is protecting you for software failures. So update domains are more or less which Hyper-V host is running your VM. So all your VMs in Azure could be on the same Hyper-V host if you don't say otherwise, but if you set up an availability set, they will be deployed to different Hyper-V hosts. That way, if the Hyper-V host itself has to be rebooted because of bug fixes or problems, then the rest of your VMs in this availability set are still running. So Azure's rule about update domains is it only reboots the Hyper-V host for an update domain one at a time. So if you have multiple VMs in this solution that are in update domain 0, it'll reboot all of those at once. Those could be offline for a few minutes, and then it waits for those to come back up and the Hyper-V host to stabilize, and then it will update the next update domain. So the default number of update domains is 5 and the max is 20. So to summarize terms, fault domain protects you from hardware faults, hardware failures, and update domain protects you from software updates or reboots as a result of software updates. An availability zone gives you a little bit of further protection because it spreads your VMs across data centers. So normally in an availability set, all the VMs could be in the same Azure data center. An availability zone says make sure they're in 2 data centers at least in the same region. So that protects you from a data center outage. You can set these up when you create a VM, but you can also set them up ahead of time. And one thing you should remember about availability sets and VMs, once you create a VM, you cannot move it into an availability set. You have to specify that when you set it up. For that reason, it's probably a good idea to create an availability set ahead of time if you know you're going to use one. It's a matter of picking resource group, a name. You need to pick a region for your availability set. I'll choose East US. And then here's fault domains. The default is 2, max would be 3. Update domains, the default is 5, max would be 20. That's about all you have to specify for an availability set. I'll review and create. Once you have one set up, they become available for your use when you deploy VMs. And I'll show you that as soon as this is finished. Okay, it's done. Availability sets aren't necessarily all that interesting to look at themselves, but where it becomes useful is when you go to create a new VM. So if I'm going to create a VM in East US, I'll call it VM2. So availability options, none, or use an availability set, and then pick the one. I see it's not shown because I chose the wrong resource group. So here's my availability set. I can choose that. And then the rest of this is just a standard setup for a VM. An availability zone is also available here as a choice. If you choose availability zone, for this VM, you need to specify which zone. So most Azure regions, especially in the US, have up to 3 availability zones. And so you can deploy a VM essentially to one or another data center. So availability sets and zones are a common way to increase the availability for a solution. They do require that the VMs that you put in them are configured to run the same software. So that's up to you to make sure that you put the same workload on each VM so that it makes sense if one VM goes down, you have other VMs in the availability set or zone that are available. A VM scale set is a set of identical load balanced VMs. The idea is all the VMs in this scale set are running the same software. They're the same size, same configuration. It's good for workloads with varying demand. Let's say you have a web application deployed to a VM, but you need essentially a server farm. You need maybe 6 different VMs that are running that solution and a load balancer in front. So a VM scale set could be a great solution for that. In a VM scale set, you only pay for the VMs that are running. If you have 6 VMs in a scale set, you're paying for 6 VMs. If you shut down 3 VMs, you'll only pay for 3 VMs. So a scale set itself doesn't cost any extra money. You're just paying for the VMs that are in it. One of the features that's really nice about a scale set is you can turn on what's called auto scaling. When you enable auto scaling, you can set a minimum and maximum number of VMs and then establish some rules that might be based on metrics, such as if my overall CPU utilization is over 70%, let's say, then please add a VM to my scale set, and Azure will automatically do that. You can also add another rule that says if my average CPU utilization drops below a certain value, then maybe you want to take away a VM. So this is a great way to just use capacity when you need it, give up the capacity when you don't, and you don't pay anything extra. You can also base your scaling on a schedule to say, on weekends, always scale up to extra VMs to handle load. Let me show you how to set up a VM scale set. So the thing to think about for a VM scale set is what you're specifying here are the parameters for all the VMs in the scale set. I'll choose East US for my region. The orchestration mode of uniform is the scenario I was just describing where all the VMs look exactly alike. You're specifying the image, 2019 data center, a size for the VM, and then the rest of this setup is similar to how you would set up a VM, only it's going to apply to the VM scale set. I'll finish setting this up and then show you the result. Okay, my VM scale set is finished. Let's go have a look. If I look at the instances blade here, you can see I have one VM running in my VM scale set. I could select individual VMs and look at some of the information about them. I can also select them here, restart, stop, fix. Under networking, this is the networking rules that apply to all the VMs in the scale set. Disks is the same where each VM will have an OS disk. As described here, you could add data disks as well. So some of the similar settings that you would specify for individual VMs. Let's talk about scaling. By default, manual scale is turned on, and so you can come and just set the instances that you want in your scale set. If you wanted 5 VMs, you could set it as 5. Save. Azure would create 4 more VMs, and then I'd have 5 VMs on my scale set. The custom auto scale is where things get a little more interesting. So scale based on a metric and add a rule. So here is, just configure the layout of this. If your average VM CPU percentage is above a certain value. So this graph just shows you what it has been in the last few minutes. You can see if it's greater than a certain percentage for longer than 10 minutes, then please increase my count by 1 instance. So that rule, just following through choices that are here, would say please scale out if my average CPU time is above 70%. You'd also add another rule. If your average CPU time, let's say, is less than 20%, then decrease count. So saving these rules would have Azure auto-scale the size of your VM scale set. The nice thing about this, again, is you don't pay any extra money for VMs that you don't need. But if you're having the load, then you probably need more capacity, and you can have Azure automatically do it for you. So in summary, comparing a VM scale set to just a regular set of VMs, you can see that the manual group of VMs, such as ones you might have in an availability set or an availability zone, the word manual shows up a lot because you have to monitor, you have to add new VMs, you have to place them in the right availability set. VM scale sets can automate much of that process for you. And in essence, they don't cost any extra money because you're not paying for the scale set itself, you're just paying for the VMs that are running. So in this lesson, we've talked a lot about creating and configuring VMs. We talked a little bit about the virtual networking for VMs, more of which we'll discuss in lesson 7. We also talked about VM disks, how to add disks to VMs, and how to manage encryption of those disks. We talked about automating VM deployment through ARM templates, and also the 2 extensions, custom script extension and desired state configuration extension. We mentioned high availability. You can set up availability sets or zones if you want to manage the set of VMs yourself. You could also set up a VM scale set if you wanted Azure to more help you manage the set of VMs. I want to call out some particular command line items, particularly for creating VMs. This is PowerShell first. There's a new AZ-VM command, and it's how you create a VM. You can call it with very few arguments, as shown in this first example. Just the name of the VM. That's all that's really required. This will prompt you for admin credentials, and Azure will take all the other defaults to create this VM. Another example that's worth looking at, though, is what if you were going to do things where you controlled the information a bit more. So in a case like that, you have to have certain resources set up before you finally create the VM. In this example, the last command is new AZ-VM, but before we get there, we have to set up the network information and a few other things as well. So the first command, new AZ virtual network subnet config, whenever you see a config word at the end of the PowerShell command, it means it's going to set up an object and initialize it and then return it to you for use in another command. So if we look to the right here of this command, we name the subnet and we give it an address prefix. So it's just information about the IP addressing for that subnet. Next is new AZ virtual network, where we're creating a network or a VNet. And notice out here, we also specify the subnet that was returned from the previous command. So we're adding that subnet to the VNet. Add a network interface, because the VM is going to need a network interface. And notice the subnet ID is specified also from the VNet, the subnet that was added, which is the one that was in the first command again. So these three lines here set up the necessary network information for my VM. I get some credentials. And then comes new AZ VM config. So again, don't create the VM yet, but give me an object which I'm going to further modify before I create the VM. So that specifies the VM name and its size. And that's all we put first. Next, we set AZ VM operating system. We reference here the virtual machine object that was returned from AZ VM config. Specify some other things like its Windows, what's its name, what are the login credentials. Add the network interface, again specifying the VM object. Set the source image, again modifying the VM object. And finally, we're ready to issue the new AZVM command. And so here, the AZVM command, we specify the virtual machine object that we'd created. So when you set up a VM this way, networking stuff you have to have established, probably set up an AZVM config object so that you can configure the operating system, attach the network interface, indicate which image from the Azure Marketplace you want to use, and then you can finally call new AZVM. Let's have a look at the Azure CLI. Here we're looking for AZVM, so that's going to take us into the module that allows us to manage VMs, and then many commands here, including setting up availability sets, but we're looking for AZVM create. So again, lots of options you can specify here, and often with AZVM create, you can specify everything in one line. So this particular example is another simple one where you just name the VM and which image. Azure will take defaults for everything else. But you can also specify options that you'd rather use. If I scroll back towards the top, you can see there are options on AZVM create for specifying the VNet name, indicating image information, what your public IP address might need to be, what network interface cards you want to specify. So all options that we would set if we were setting this up in the portal are available as options here on the AZVM create as well. Welcome to Lesson 7, Manage Virtual Networking. In this lesson, we discuss what a VNet is and how it supports VMs deployed to Azure. We begin by discussing how to create and configure a VNet and how to secure access to a VNet. We then learn how to connect VNets to other resources in Azure and on-prem resources outside of Azure. We finish the lesson with techniques for monitoring and troubleshooting VNets. A virtual network, or VNet, in Azure is a private network for your VMs. If you put several VMs in Azure, you may want them to be able to communicate with each other, and so Azure allows you to set up a private network and you can use private IP addresses. Each VNet has an IP address space. So all the VMs on the VNet have to come from that IP address space. Typically you use one of the non-routable IP address spaces like 10.0. A VNet also has one or more subnets. So a subnet is just a logical subdivision of a VNet. It allows you to further subdivide a VNet, a large VNet, into smaller pieces. And as we'll see, it can play into network security as well. It's important to understand too that a VNet is scoped to a region. So when you create a VNet, you set it up in a region, and that's where it lives. Here you see a picture of a virtual network on the right that has multiple subnets. So the production subnet has some VMs. We'll talk about these various components as this lesson unfolds, but you can use a VNet in Azure to talk to on-prem resources. You can use a VNet in Azure to even talk to other VNets. When you're setting up your VNets and subnets, it's a good idea to remember, in fact it's a requirement, that an Azure VM has to be on the same, in the same region where your VNet is. So if you have VMs in East US, you will necessarily have a VNet in East US. If you also have VMs somewhere else, like in West US, then you must have another VNet in West US. As I said previously, subnets are a logical subdivision of a VNet. So it's a good way to organize or group your VMs, maybe by type. You might want your web VMs to be on a particular subnet of your VNet so that you could control the security for those VMs differently than you would, say, database servers on a different subnet. VMs by default are assigned an IP address from the VNet address space when they boot up. So Azure keeps track of the address space and it hands out IP addresses that haven't been used. All VMs on a VNet can communicate with other VMs on the same VNet. So this private IP address space has IP connectivity. However, by default, VMs cannot communicate with VMs on a different VNet. We'll talk about the mechanism to turn that on, but by default, all the VMs in a VNet talk to each other, but not to VMs outside of that. Let me show you how to set up a VNet in the portal. So here I am in the marketplace. I'm just going to search for virtual network. Virtual network needs a resource group. I'm going to create a new one. Oh, I have one called West RG. I'll use that because I want to make a VNet in West US. And I will call this, no, I'll leave that. So IP addresses next. We need to specify an IP address range. The portal has already seen I have a 10.0 VNet, so it's suggesting 10.1. The /16 means that there's 16 bits. The first 16 bits are net ID. So all the VMs on this VNet will start with 10.1. I need to have at least one subnet on the VNet. And you can see I have a default here. I'll just leave that. I'll leave these as well. Some of these services we will discuss in later lessons. Review and create. VNets don't cost any money because they're really not any physical infrastructure. It's just some bookkeeping that Azure keeps track of for VMs that are going to be deployed. When it's finished, I'll show you the VNet. And it's done, so let's go to the resource. You can see my VNet has an address space as specified, has subnets as specified, no connected devices. So what would normally show up here would be any VM network interfaces that were attached to this VNet. So VNets are a necessary part of having VMs in Azure. If you have VMs, you'll have VNets. In fact, you'll have VNets where the VMs are. If you don't have VMs, you may not have VNets. You don't really need them for platform services. A network security group is like a virtual firewall. It establishes inbound and outbound traffic rules for VMs that sit on VNets. A network security group is either bound to a network interface, which the VM has at least one network interface so it can connect to the VNet, or a network security group can be bound to a subnet. This feature will help us as we manage the security of the network. In this picture here, you can see that there's a network security group attached to this network interface that connects to this VM. And there's another network security group that's attached to the subnet itself. So you can have a network security group either to a NIC or to a subnet or to both, but realize if it's applied to both, then both sets of rules apply. I'll talk about how the rules work in a moment, but you can use this to your advantage if you're setting up, let's say, several web server VMs. Put them all on the same subnet and then apply the network security group to the subnet level. It could save you the trouble of having to set up individual inbound rules for VMs on the subnet. A best practice when you're setting up VMs in Azure is to create your VNets and subnets first. That establishes your IP address space. And also the subnets, if you think through the design of what kind of workloads. Am I going to have database servers, web servers? What ports do I want open for web servers? So having that all laid out in your mind or on paper ahead of time is a great idea. Then create your network security groups, because you can go ahead and set up rules for subnets and network security groups. Then when it comes time to create your VMs, you can just place them on the VNet, assign the NSGs if you need any individual NSGs, and then you're done. And then your network security is already established. So a network security group itself has several items associated with it. There's a priority, which indicates the order in which the rules are evaluated. Rules are always evaluated in increasing priority order. When a rule in the NSG is matched, the search concludes and it doesn't look at any other rules. And then the action is taken. And so the action is either allow or deny. There are some built-in rules. They all start with priority 65,000 and above. You can't delete them, but you can just override them with a higher priority rule. Let me show you an NSG for a VM that I have in the portal. So here's VM1. You can find some good networking information on the blade here. Here's a summary of the network security group rules for inbound and outbound, but I can go look at details of the NSG itself here. So this particular NSG, notice, is bound to the network interface for VM1, and it's that IP address. Currently, this NSG is not bound to any subnets, but I could associate it with a subnet if I wanted to. I won't do that now, but I want to show you the rules and what they mean. So on the overview blade, we can see inbound and outbound rules. So inbound, by default, for a network security group, there are these three rules. We allow traffic from any other IP address on the VNet. So allow VNet inbound. We also allow inbound traffic from a load balancer if you have an Azure Load Balancer, in case this VM might be behind a load balancer. Notice everything else is denied. So by default, you can speak to other VMs on your VNet. The outbound security rules, you allow VNet outbound traffic. You allow internet outbound. So if you're on the VM and you can open a web browser and connect out to the internet, that works. Everything else is denied. So this would include VMs on other VNets, unless you set up some additional rules, which we'll discuss later. So this VM also has one additional rule that was added when I set up the VM that opened port 3389, source of any. Let's say I wanted this VM to also have port 443 open. If I want to add a rule, I go to the settings, inbound security, rules, and I add. Fill this out. My source can be anything, or you can give a list of one or more IP addresses. You could also choose a service tag, which are types of Azure services, or special things called application security groups, which we won't discuss in this lesson. Your source port range can be anything. You could specify an individual port. Typically, if someone is inbound, you don't know what their port is, and so asterisk makes sense here. Destination, in this case, we'll just say any, so we don't have to specify a specific IP. But we can choose something like HTTPS as the service, which says, oh, well, that's port 443 over TCP. So it pre-selects my port and protocol, and then I would want my action to be allow. I need to assign a priority, and I need to consider the rule that priorities are evaluated, or rules are evaluated in priority order. So 310 sounds like a good idea. I'll change this to 443, just as a rule name, and add that. And so now any web traffic over 443 would be allowed in or across this network security group, and since it's attached to my VM, then it would be allowed into my VM. You can see how you'd want to carefully design the rules and the priorities for the rules, and then try to group these as much as you can. So set up NSGs for different kinds of workloads, and then apply them most likely to subnets, possibly to VMs if you need to make some special rules to override. As we have discussed, all the VMs on a VNet can automatically communicate with each other over private IP. If you have multiple VNets, however, VMs on different VNets cannot see each other automatically. A way to solve this is to set up what's called a VNet peering. Any two VNets you create in Azure can be connected using peering relationships. The VNet peering communication uses the Microsoft backbone and not the internet for communication. The data is private because it's on the Microsoft backbone, but it's not encrypted. They're quick and easy to set up. You can have up to 500 peerings per region. And the cost for a VNet peering depends on how much data you push over that peering connection. Let me show you how to set one up in the Azure portal. Here is a VNet. I have East VNet. Scroll down to peerings, and I can easily add a new peering. Notice when you set up a peering, you set up two relationships. It's really a peering connectivity in one direction and then a corresponding peering in the other direction. So I'm in East VNet. I'm setting up a peering from east to west. You need to be able to answer these questions for your peering relationship. Do you want to allow traffic to your remote VNet? In my case, it will be the West VNet. Do you want to allow West VNet to forward traffic through my VNet? That's a question you need to be able to answer. And then lastly, do you need any additional routing, or do you want to use the Microsoft default routing? We're just going to use the Microsoft default routing. I then set up the peer in the other direction. This will be west to east. Use Resource Manager just so it can search for my subscription and the VNets. So here's my West VNet. I answer the same questions here that I answered in the other direction, and I click Add. And notice that Azure is setting up peerings in both directions. When they're done, I'll be able to see them both from East VNet and also from West VNet. My peering is still setting up. You can see its status is updating here, but I can go in and look and see the choices I made on the east to west side. And if I were to go to the other side, I'd see the corresponding settings on the other side. The thing to think about for peering is how you want to design your network. You should make a drawing first. So put this on paper, put this in some kind of software tool so you can visualize your VNets and how you want to connect them. Then you'll be able to answer the questions as you set up the peering. In this particular example, from VNet A to Hub VNet, a peering is established. And so if I want VMs on VNet A to talk to Hub VNet, I need to allow traffic to the remote VNet. The question about whether traffic goes from VNet A to VNet B, in this particular drawing, I need to rely on the second choice. So traffic forwarded from the remote virtual network. You may want to set up a peering between A and B, but if you do not, then you need to allow forwarded traffic through Hub VNet to get from A to B or from B to A. If you have any exam questions on this, then think through the information given about what peerings exist, and that will help you decide whether traffic is allowed. And since when you set up a peering, it sets it up in both directions, you can selectively enable or disable traffic in one direction or the other. Typically you enable it in both, but it could be disabled in one direction. So Azure's default routing rules handle most situations for VMs that need to communicate in Azure. Peerings that you set up, those rules are automatic and usually what you want. If you set up VPNs or express route gateways, which we will discuss later in this lesson, then those have routing rules built in as well. If you need to customize routing, you use what's called a route table. You can create a route table in the Azure portal, and then you associate it with a subnet, and then define routing rules for VMs that are on that subnet. You can either route to a virtual appliance in case you need to go through a specific VM or other NVA in order to, say, log or assess traffic. You can route to the VNet itself or to a VPN gateway that's attached to this VNet. You can also route out to the internet. Let me show you that in the portal. Here's the route table I created from the Azure Marketplace. The first thing you might want to do is configure routes. Let's say that I have a network virtual appliance on my VNet that wants to inspect all incoming traffic on my VNet subnet. So I'm going to give this route name to NVA. So the address prefix, if it's bound for 10.0.0.0/24, so that's a particular subnet, then my next hop is going to be virtual appliance, and then I just put in the IP address of that virtual appliance. So you can add other routing rules as needed. Other routing rules you might have would allow you also to connect to pass traffic out to the internet, to just take the incoming traffic and send it to the local VNet, send it to a particular virtual network gateway, or none. The none choice here says just discard the packet and don't forward it. The other thing you must do when you set up a route table is bind it or associate it to a subnet. So you can see here, I need to pick the VNet is the VNet where in the same resource group as my route table, and then I just pick a subnet on that VNet. So I have specific routing rules for this route table, and it's bound to a subnet, therefore I can control traffic in non-default ways. Azure has a new service called Azure Route Server, which is a managed service to route between an NVA and a VNet. In the diagram you see here, the Azure Route Server is something you set up in the Azure Marketplace. It learns about other networks it's connected to using Border Gateway Protocol, and then can propagate that information to VMs on the VNet. It does also work with peered VNets as well. You must have a subnet called Route Server Subnet on the VNet where you're going to set up an Azure Route Server. And the network prefix has to be 27 bits or smaller so that Route Server has enough room for IP addresses that it might need. Let's now talk about service endpoints. So many times you have VMs in Azure and they want to talk to data that you have deployed in Azure as Azure services. In the diagram you see here, there's a VM on a VNet and maybe an Azure storage account, and there's a workload running on the VNet that wants to communicate with the Azure storage account, maybe to read some data from Azure storage. So one way to do that is to set up what's called a service endpoint. It's an endpoint to a specific service in Azure, like a storage account. When you set up a service endpoint, it uses the Microsoft network to communicate. It also disables access to the storage account over the internet. Typically, the PaaS services that serve data are the ones that allow service endpoints. So you got a workload running on a VM. It needs some way to talk to a PaaS service that you have set up in Azure, like SQL database or storage, and you can set up an Azure service endpoint. Let me show you how to do that. I'm going to go to my storage account, scroll down to networking. By default, storage is visible on all networks, which means it's on the internet. There's a public IP address behind the scenes that's used to connect to it. You can, however, set up selected networks and then add an existing VNet. I need to pick one that's in the same region as my storage account. Pick a subnet and enable. So that will allow VMs on that VNet to communicate with this storage account. Notice on this page too, you can also do other kinds of restrictions or allows for communication with my storage account. You can choose IP address ranges here as well. So service endpoints have been around for a long time. They're one way to communicate between a workload on a VM and something in an Azure storage service or database. And then the thing to note in finishing this topic is that the VNet and the service must be in the same region. Let's contrast that now with another way to set up endpoints called private endpoint. So this is an alternative for platform service connections where you have workloads running on a VM that want to talk to an Azure service you have deployed. The diagram here is more complicated, but it's worth studying to understand the difference. So in a private endpoint, what you get on the subnet and the VNet, where the VM is located, is actually what's called a private endpoint resource, and it is assigned an actual private IP from your VNet. And so your workload running on the VM can use this private IP to talk to the private link service that's in front of whatever your service is that you want to communicate with. So the big difference in a service endpoint and a private endpoint is a private endpoint uses a private IP address. Using private IP communication, it's almost as though the service was deployed to your VNet. But note that the VNet can be in a different region than the service. So private endpoints are much more flexible. in that your VM could be running in East US, your storage account could be in West US, and you can still have private IP communication. Azure handles all the routing in between. So many of the same services are supported for private endpoints, even Azure Load Balancers, because those are often front ends to some data service that your workload might communicate with. You set up private endpoints in the same place in the portal that you do service endpoints. So here's my storage account, and let's say I want to allow VMs on a VNet to see the storage account by private endpoint. At the top of this networking blade, you can see private endpoint connections. So my storage account is in West US 2, but I want my private IP address to be from East VNet because that's where the VM is that's going to connect to this storage account. So I'm going to choose the resource group of East RG, and I'll call this my store 2 endpoint. Region East US. I need to pick the resource. It is my storage account. I can choose, let's say, the blob service. For configuration, so East VNet is the VNet that's available in East US that I have. And I need to pick a subnet, and it's going to pick one of the IP addresses from the subnet and assign it to this private endpoint. You can integrate with private DNS here if you like. It's going to create or make available a private DNS name, which you can use here if you like. And when this is finished, I'll have a private endpoint connection in East US on East VNet that allows connections to my storage account, which is in West US 2. In summary for this section, just remember that service endpoints require that the VNet and the service be in the same region. Private endpoints allow them to be in different regions. And so in that way, they're a little more flexible. I want to begin by discussing VNet to VNet connections. In the last section, we talked about VNet peerings, which is a way you can connect any two Azure VNets together. Another way to do that is what's called a VNet to VNet connection. This sets up essentially a VPN connection between two Azure VNets. It's similar to what we will discuss next, which is a VPN connection between an on-prem network and a VNet. Data is passed through an encrypted tunnel when you set up a VPN connection. If you remember when I mentioned VNet peerings, I said it passes over the Microsoft backbone, but it's not encrypted. In a VPN connection like this, it is encrypted. When you set it up, you specify a type. If you choose VPN type, it uses public internet as the network. So the data can pass to different regions, East US, West US. It would pass over the internet, but through an encrypted tunnel. If you choose a type of express route, it does use a private leased line connection, does not use the public internet. The cost for a VNet to VNet connection is based on its bandwidth and its SKU. And then there's some additional costs for interregional data retrieval. So let's compare this to what a site-to-site connection looks like. A site-to-site connection is a VPN connection between an Azure VNet and an on-prem network. Very similar to a VNet to VNet. In fact, the setup is almost the same, as we'll see. This is very useful if you have a workload running on-prem and maybe it wants to connect to something running in Azure, or vice versa. Essentially, these two networks, your Azure VNet network and your on-prem network, share an IP address space. So they can communicate essentially over private IP, even though there's an internet in between them. So if you have a collection of VNets in Azure, you might set up peering relationships for them, or maybe VNet to VNet connections. And then when you set up a site-to-site connection between an Azure VNet and your on-prem network, then suddenly you have this extended network capabilities so that resources on-prem can see potentially any VM resource you have deployed in Azure. So setting up a VNet to VNet connection. Let's talk about the steps and the resources involved. First of all, set up your VNets and subnets. They could be in the same region or in two different regions. You must have a specific subnet called Gateway Subnet on each VNet. The network prefix must be 29 bits or smaller. Even 27 bits or smaller is recommended. You then create a resource called a virtual network gateway, represented in the picture here. So the VPN gateway is what's going to do the routing between the VNet and things outside the VNet. When you set up a VNet gateway, you choose its type. It's either VPN or ExpressRoute. You choose its speed or SKU. Typically, you add a public IP address as well because the VPN gateway, anything connecting into this VPN gateway needs to know what the IP address is to get to it so that it can distribute network traffic on the VNet. So you set these up on both VNets. When that's finished, you create another resource called a VPN connection. You set that up in a VPN gateway, and what that does is identify the remote network. So for the VPN gateway in East US, you add a VPN connection to West US, and in the end, any traffic on VNet 1 that doesn't fit on VNet 1, that has a 10.41 address, the VPN gateway picks it up and it forwards it over the secure tunnel to the remote network. Let me show you how to set these pieces up in the portal. I have two VNets, East VNet and West VNet. East VNet is in East US, West VNet is in West US 2. I do not have any peerings between these two networks. I'll go to East VNet, look at the subnets. I'm missing the subnet needed, and I can add it here. Add a gateway subnet here. Azure fixes the name. Pick a subnet address range. I'll leave the default. I don't need to specify any other options here. I can just click Save, and Azure adds that subnet for me. If I look at West VNet, we already have that gateway subnet created. The next step is to create a virtual network gateway. I'm going to go to the marketplace and create the VNet gateway. I'll start with East US, so I'll call this the East Gateway or the East VPN. I'm going to choose VPN type, my SKU. The VNets that are available in East US, there's only one, it's East VNet. I also would want to create a public IP for connecting into this VPN gateway. I can review and create. VNet gateways can take some time to set up, sometimes half an hour or more. I'll pause the video when this is finished after I've created the one for West VNet as well, and we'll talk about setting up the VPN connection. Okay, my virtual network gateway is set up. Let's look and see what I have. Here's East VPN. If I go down to connections, I can now add a connection. And what do I want to connect to? I want to connect to the VPN gateway on the other side. So this is going to be a VNet to VNet connection. I'm at East VPN. I want to select West VPN. I need to type in a shared key. This key will be used by both sides to do encryption. So obviously it needs to be complicated, random, and known so that you can type it in on the other side when you set up the connection as well. So when you get this finished, you can click OK. Oh, I've got to give a name to this. I would do the same on the other side, specifying the same shared key, and then I would have established the picture that we see in the slide. So, establishing this connection between the two VPN gateways, between the two Azure VNets. So, there's a lot of similarity to doing this and setting up a site-to-site connection. For site-to-site connection, Azure VNet is going to be on one side and your on-prem network is going to be on the other. So first you set up your VNet and subnet in Azure. So you do need to have a gateway subnet set up on your VNet. Then you also set up a virtual network gateway in Azure. You just need one of those and it attaches to your VNet. So the setup for that is the same. And then the extra resource you need here is what's called a local network gateway. You can create one of those in the portal. All it really indicates is the IP address space of your on-prem network. So it's not a resource per se in Azure, it's not infrastructure deployed, it is information about what IP addresses are on that other side. After that's finished, you create a connection between the VPN gateways. You do have to set up something on-prem. You need some kind of either software or hardware gateway that you set up on the on-prem side. But the local network gateway you set up in Azure represents that resource. And then in Azure, what you would do, come back to the VPN gateway you have in Azure, add a connection, change the type to site-to-site. And notice here it's asking you to choose your local network gateway. Still the same configuration of choosing a shared key, which you'd specify on the other side as well. ExpressRoute we'll talk about in the next section. So setting up a VPN gateway between two VNets is similar enough that I wanted to show you how to do that in the portal. The site-to-site connection I cannot do because I don't have an on-prem network, but since the setup is basically the same, I think you can extrapolate any differences. The last thing to discuss in this section is ExpressRoute connections. So ExpressRoute connection is, you could just say, a fast VPN. It has some other features, but it's a private connection from your on-prem network into Azure. So it's similar to setting up a VPN gateway. In fact, you go and set up a virtual network gateway in the marketplace, and you specify its type as ExpressRoute. You then have to contact someone in your area that will hook you up to the internet with a private connection. This is a great way to connect to VM workloads you might have set up in Azure if you have resources on-prem and they need to speak to stuff you have deployed in Azure on VMs. You can use an ExpressRoute connection to do it. You can also connect to other cloud services. So you can optionally enable the ability to connect to things like Dynamics, Microsoft Office, other services you might have deployed through Microsoft that aren't necessarily your resources in Azure. When you set up an ExpressRoute connection, you automatically get two connections, a primary and secondary connection. You can either have the secondary be a failover, you can also set them both as active and share both the bandwidth of both connections into Azure. So the two main ways to connect Azure VNets to on-prem resources are site-to-site connections, which use VPN gateways of type VPN, or ExpressRoute connections, which use VPN gateways of type ExpressRoute. So to finish up our discussion of VNets, let's just talk about a few best practices. Before you start deploying VMs in Azure, it's a good idea to create VNets. Since you know that VMs have to live on a VNet, wherever you want VMs, you need to create a VNet there. Create your subnets based on VM workloads. Maybe you have a web subnet where you're going to deploy web servers and you can open specific ports using network security groups. Maybe you have others like a data subnet or SQL subnet where you deploy SQL servers. Those would have very different network security groups and different rules. Choose your IP address spaces carefully when you set up your VNets. If you can, avoid any overlap with other VNets and even your on-prem networks. That way, when you set up peering relationships later or site-to-site connections, then you don't have any IP address conflicts. Also a good idea to create your network security groups ahead of time. You could have done it all when you set up your subnets, but having those established before you start creating VMs means that when you're ready to create VMs, you can just choose the VNet, choose the subnet, the network security group is already established, and then the VM comes online with the right security in place. Network Watcher is a resource in the Azure portal that collects together a set of tools you can use to troubleshoot your network. You can see the list of diagnostic tools on the right. I'm going to give a high-level view of them here, and we'll take a quick look in the portal as well. You'll see some exam questions on troubleshooting networks. And so knowing the differences in these tools and which one is appropriate for the problem that's presented is the way to be able to answer these questions correctly. So IP Flow Verify is a tool that checks packet travel to and from a VM and some other IP address. So it uses a 5-tuple, which means source, IP and port, destination IP and port, and a protocol. You specify those 5 things, and IP Flow Verify will just tell you yes or no, will the packet travel from the source to the destination. You might use this from a VM if it's having trouble connecting to a remote VM that's somewhere else in Azure, or perhaps to someplace else on the internet. NSG Diagnostic is a tool which looks at the sum of all the NSG rules that are applied from source to destination. So again, if you imagine you have 2 VMs in Azure, remember a VM can have a network security group attached to its network interface and also to the subnet it sits on. And so between source and destination, you could have up to 2 NSGs for each and 4 network security group sets of rules that are applied for inbound and outbound traffic. And so the diagnostic can help you troubleshoot whether you have an NSG conflict problem. Next Hop is a tool which allows you to just look at where would the packet go from this VM next on its way to the destination. So, it could be another VNet. If you have a peering relationship set up with other VNets, it might be that you need to hop to that VNet before you can get to the internet, before you can get to an on-prem resource. Continuing these tools, there's one called Effective Security Rules. This is all a combination of NSG rules for a VM. We've seen this already, and you can find it in the portal in the VM blades, and specifically the networking blade for VMs. So it also lists the very same information of the effective security rules for a VM. And that would include rules applied to the network interface and also NSG rules that might be applied to the subnet. VPN Troubleshoot is a tool which is just that. It helps you troubleshoot VPNs. You would not use it if you didn't have trouble with a VPN connection. So if you see a question about a VPN that's not working correctly, then VPN Troubleshoot is your tool. Packet Capture is a tool that captures all the network packets to or from a VM. You must supply a place to store these packets when they're captured. You can either store them in a file on the VM itself, or you can specify an Azure storage account. You would typically only turn this on for a brief period of time while you're troubleshooting very low-level networking, and then you turn it off when you're done. Connection Troubleshoot is a tool that creates a TCP connection and really works that connection between a source and destination VM. The source and destination VM could both be in Azure, one could be on-prem. This is the one tool that requires you to install some software, so you need to have the Network Watcher extension installed on the source VM, because it opens the outbound connection from source to the destination, and then the troubleshoot does its work. Let me show you where to find these in the portal. So Network Watcher is not listed on the menu by default. You can easily find it in the search box just by typing Network Watcher. And you see here, here's the list of diagnostic tools. I won't go over all these again, but if you just walk down through here for IP flow verify, you can see that you specify the VM you want to work with, whether it's inbound or outbound traffic, the local IP address and port, the remote IP address and port, and then protocol. That's your 5-tuple, and it'll tell you whether the packet will arrive or be allowed from source to destination. For NSG diagnostic, again, you specify things like your resource group, and I'm going to check a VM, and you pick your VM, and then it'll summarize all the NSG rules from source to destination. Next hop also has you just pick from the list of items here which network interface on a VM, what's the source IP, what's the destination IP, and then how would the packet travel to get there. Effective security rules. You have to pick a VM here. It'll load the network interfaces. And then you can see the effective rules for that network interface. Realizing there could also be some subnet rules applied. VPN troubleshoot. Start troubleshooting. You need to have a VPN connection for this to be of any use. Packet capture. You notice when you go to add one, you have to specify here either an Azure storage account or a file you're going to put on the VM. Connection troubleshoot. Specify information about the VM for source, destination. You do need to make sure that the Network Watcher extension is installed. I would just do a high-level review of what these are called and what it sounds like they do, and what they're useful for. And I think you'll be able to answer those monitoring questions. Now, there's some other uses in Network Watcher. There's a tool called Connection Monitor. So this provides a deeper kind of connection, end-to-end connection monitoring for VMs. They could be Azure VMs, they could be other kinds of VMs, on-prem VMs. When you set up Connection Monitor, you have to store data in what's called a log analytics workspace. So we'll talk more about that in lesson 11. Connection Monitor is good to troubleshoot slow and broken connections. So the slow part might be a good clue for exam questions too, because more than just checking whether connectivity is possible, it can also compare network latencies. So it'll watch the connection over time and compare latencies from different regions for data that's traveling. So Connection Monitor, it can be useful for that. You'll find Connection Monitor here. The Connection Monitor Classic and Network Performance Monitor are being deprecated for Connection Monitor. Also, there's some logs available in Network Watcher. So NSG flow logs capture IP packet info, not the whole packet, but the IP headers and so forth on the packet that flow through an NSG. And so this can also be another way you could check NSG flow or NSG rules. When you set up an NSG flow log, you have to write it to Azure Storage. Diagnostic logs are logs and metrics for networking resources. They are stored in Log Analytics, can also be stored in Azure Storage. You'll actually find this also in the diagnostic settings for a particular portal resource. Let me show you what I mean. So if I scroll down here in Network Watcher to Diagnostic Logs. So here are the resources I have that have diagnostic logs I could enable. There's a network security group. There's a VM, a network interface. That's a storage endpoint I have. Let's look at the NSG. So diagnostic logs are things you can enable on a particular resource. You pick which categories of diagnostics you want to capture, and then you specify where you want to store them. Either Log Analytics Workspace or Storage Account, or stream them somewhere else. So this information is duplicated from the information you'd find if you went and looked at the NSG, scroll down to monitoring, look at diagnostic settings, and you see the very same screen. So the screen we see in Network Watcher is just a convenience while you're working in Network Watcher itself. The last item is Traffic Analytics. So Traffic Analytics, analytics in the name indicates that it's going to provide some additional analysis. So if you turn on Traffic Analytics, you must have NSG flow logs turned on, and then Azure will monitor the flow logs and provide deeper information. For example, it can visualize network activity, show you hotspots in networks. So maybe in a big sprawling VM deployment where you have regions, VNets in several places, and you have hub and spoke topology. Are NSG flow logs going to show you where you might have a hotspot in your network? Yeah, it can really help with that. You can also look for security issues, understand that traffic flow across regions. This also requires data to be stored in a Log Analytics Workspace. And there are some specific permissions you need for Traffic Analytics. So at the subscription level, so think the subscription level is way up at the top, right? That's the billing level. So underneath subscriptions are resource groups and then resources. But specifically at the subscription level, you need either owner, contributor, reader, or network contributor. So network contributor is one of the permissions you could use to be able to capture and analyze this data in Traffic Analytics. So you may deploy a lot of resources on VMs and VNets in Azure and never run across a network issue, but I would encourage you to study some of the tools available under Network Watcher just to understand their differences for your exam. So in this lesson, we've talked a lot about VNets. Virtual networks in Azure have an address space. They have to have at least one subnet. Usually you set up network security groups when you set up your VNets so that you can control inbound and outbound traffic, both to network interfaces for VMs and also to subnets. We talked some about VNet connectivity. One would be service endpoints, another private endpoints. So in both cases, the endpoint effectively gives a VM workload access to an Azure service, such as a storage account or Azure SQL, something like that. A service endpoint must be in the same region as the VM that is connecting to it. A private endpoint is different. They can be in different regions. So the service itself could be in one region, the VM could be in another region. Private endpoint essentially assigns a private IP address from the VNet where the VM resides. And so the VM thinks of it as a local access. We also talked about peering, which is one of the ways you can connect to Azure VNets. It's very quick and easy to set up. Can be a nice way to connect VNets if you have multiple VNets in Azure. You can also set up VPN type connections in Azure. You can either do a VNet to VNet connection over VPN. You can do a site to site connection, which could be an Azure VNet to an on-prem network. Whenever you set up a VPN gateway, the type is either VPN, which means it's going to use the public internet, or ExpressRoute, which means it's going to use a private line to connect up to Azure. We mentioned some of the tools in Network Watcher, some of the troubleshooting tools that can help you solve network problems. Let's talk about a few command line highlights. So in PowerShell, new AZ virtual network is the command that will help you create a new network. Here's also new AZ virtual network gateway for creating a VPN gateway. If you're looking for things like subnets, there's a new AZ Virtual Network subnet config. So that creates the config object in PowerShell where you configure the subnet and then you add it to your virtual network. For things like peerings, there's a remove, there's an add peering. So it's not a new AZ Virtual Network peering, it's an add because you add the peering to an existing VNet. Let's look under the Azure CLI. What you'll find in the CLI is that almost all the network stuff is under the command AZ network. So I'll go into that command and you can see lots of choices here. Yes, under VNet, let's do summary here. So AZ network VNet create and delete and so forth. Here's also how to add peering, AZ network VNet peering, peering create, etc. AZ network VNet subnet create. So almost all the AZ commands are going to start with AZ network, and then many that relate to this chapter are going to have VNet next, and so forth. I would do a high-level pass related to the topics we've discussed in this chapter, and I think you'll get the keywords that will help you as needed for these questions. Welcome to Lesson 8, Implement VM Backup and Recovery. In this lesson, we discuss disaster recovery for VMs, an important component of business continuity. We learn how to protect VMs running in Azure and on-prem via backup to a recovery services vault. We also discuss how to take that protection further through site recovery, a process that continually replicates a VM to a secondary region. Backup is an important way to protect VMs that you have running either in Azure or on-prem. The diagram you see here is a little busy, but let's just point out a few things. When you are deciding to set up a backup for VMs and you want Azure to help, you'll need what's called a recovery services vault, and we'll talk about those a lot in this lesson. You can back up workloads that are running in Azure, Azure VMs, also files that are on VMs that are running in Azure, also files in Azure Storage. Notice you can also back up on-prem servers as well to an Azure Recovery Services Vault. As we'll see, the Recovery Services Vault have built-in replication. You can control how much of that you want and need, and it follows all the same security rules and protocols that Azure puts in place. So, what can you back up? You can back up Azure VMs. This uses what's called the Azure Backup Agent. On Windows VMs, it can do an app-consistent backup. It uses a Windows service called the Volume Shadow Service. App-consistent backups are particularly useful for things like database, like SQL Server VMs, because they can coordinate with the SQL application and make sure that data is flushed to disk during backup. On Linux, there's not an equivalent for app-consistent backups, but it does file-consistent backups on Linux VMs running in Azure. You can also back up files and folders on VMs, either VMs running in Azure or on-prem. This uses an agent called the Microsoft Azure Recovery Services agent. It's quite a mouthful, but MARS agent is often how it's listed in the documentation. Notice that file and folder backup is Windows VMs only because there is no MARS agent for Linux. For on-prem VMs, Windows VMs particularly, there's a tool you can use called the Microsoft Azure Backup Server. So that's often abbreviated MABS or MABS. This tool is installed on a Windows box. So MABS server is software installed on a Windows box, and it supports VMs on-prem that are running Windows or Linux. First thing you need to do to initiate backups in Azure is to set up a Recovery Services Vault. Very important rule, the vault must be in the same region as any Azure VM that you want to back up. A vault has redundancy, and you can choose redundancy when you set it up. Locally redundant, zone redundant, and geo-redundant. These follow the same kinds of rules we saw in Azure Storage, where you can have 3 copies in one region, or you could have 3 additional copies copied to a second region, as in geo-redundant. When you set up a backup, you will also use a backup policy. So the policy just controls the frequency and data retention for the backups. You can choose daily, weekly, monthly, or yearly, up to 10 years. So 10 years is the max you can store backups in a Recovery Services Vault. You can share policies across any backup jobs in the vault. Notice that soft delete is enabled by default. So when you delete a backup, it's retained for a certain number of days before it's physically deleted and not recoverable. Let me show you how to set up a vault in the portal. So we look up backup and site recovery. I will do a create here. I'm going to pick a new resource group. My vault name. I'm going to put it in East US because I have a VM in East US. That's really all there is to creating a Recovery Services Vault. So while that's creating, let's talk about the process of backing up various things to the vault. If you're going to back up an Azure VM, as I said, you need an agent. There's a Azure Backup Agent. That agent can be installed the first time the backup is done. So the VM extension is automatically installed by Azure. The initial backup is full. There's a full backup, and then after that it is incremental backups so that the size and length of time needed for the backup goes down. If you are running SQL Server or SAP HANA on an Azure VM, then you can get an app consistent backup. That just means that Azure Backup coordinates with the application to make sure that any data is flushed to disk. If you want to back up files and folders, this is where you need the MARS agent. The initial backup is full. It copies everything of the files and folders you select, and then it just does incremental backups thereafter. This is supported for Windows VMs on Azure or Windows VMs on-prem servers. And the Mars agent has a user interface. When you install it, you configure on the client side what files and folders you want to backup, and those backups happen automatically. Notice they happen over port 443, which means you don't need any special connectivity to Azure. It can use your internet connection to back up the data. You must install the Mars agent on every VM that is going to do file and folder backup. And that's different than backing up other kinds of on-prem workloads. In that case, you install what's called the Azure Backup Server, or MABS. So the Azure Backup Server is a whole server environment. It's a tool or an application you install on a specific server in your environment, and it coordinates backups from all the on-prem resources you want to back up into your Recovery Services Vault. You can do Windows and Linux VMs, special backups for popular Microsoft products like Exchange, SharePoint, and SQL Server. You can also do Windows files and folders. Typically, you only need one MAB server in your whole backup on-prem environment, and it can coordinate with a vault. So let's set up backup on my Azure VM. I'm going to go and look at my VM. On the VM itself, there's a blade called Backup, and you can use this blade to coordinate or start a backup. First, you have to choose a vault. I'm going to pick the one that I created, which is in the same region as my VM. I'll just use the default policy, which is daily at 5:30 UTC time, enable the backup. I can just enable it from here, and Azure will submit the deployment and begin the backup. I'll pause the video and show you what it looks like when it's finished. Okay, the first stage of the backup is set up. I'm looking now at the Vault resource, East Vault, and if I scroll down here and look at backup items, I can see I have one Azure VM that I'm doing backups for. If I go and look at that VM, VM1, I passed the pre-check. Notice that the backup has not started because it hasn't hit this time on the schedule, but I can do a backup now. Indicate how long I want to keep this backup, and Azure will trigger the backup for the VM. When this backup is complete, I'll show you how to use the backup in the vault to restore your VM. Okay, so my backup is finished enough that I can show you the results. I'm looking at my East Vault, and I've got one backup item, an Azure VM. So this data shows failed because I inadvertently started a second backup after the first. The first one is almost finished, but there's an app consistent backup that's ready. It's a snapshot that's ready. So this could be used for restores. And I'll talk about restores in just a moment. You can also scroll down in the vault and look at backup jobs. This is a nice way to just look at the status of things that are completed, in progress, perhaps failed. There you see the second backup I started while the first one was underway. So let's talk about the restore process. So if you have an Azure VM that you've established backups for, it comes time to need one of those backups out of the vault for a restore, then what's the process? The first process we'll discuss is the full restore of a VM. You have to choose a restore point, and then you create a new restore type for a whole VM or restore disks. So terminology here is a little bit tricky, but the idea with creating a new VM is I want to stand up a whole new VM. It'll have a different name, but it'll have the same disks that the original VM had. This could be good if you wanted to duplicate a VM. Restore disks extracts the VHD files from the backup and just creates those as files in Azure Storage, and you can use to build a new VM from those if you want. So those are similar, but the first one actually creates a new VM of a certain size and you start being charged for it. The second one just has disks. The other choice besides creating a new VM or some disks is to replace existing. When you replace existing, it overwrites the existing VM with the backup. That would maybe be useful in a case where the original VM is completely non-bootable and you have to go back in time to when the backup was taken because you know that was good, but there's no point in keeping the existing VM because it's of no use. If you use a replace existing, it has to be a VM that has unencrypted disks and managed disks. So in other words, disks that Azure manages in its own storage. The other choice for restore is what's called files and folders. So with file and folder restore, you also choose a recovery point. But then Azure generates a script which you run on a local machine and it mounts the disks as network drives for up to 12 hours. You can unmount those disks when you're finished, or Azure will unmount them automatically 12 hours later. This is good if you just want to pull a few files off of the disk that's in that VM backup. Maybe the VM is not available, or maybe you want a previous version of the files. The VM works, but you want an old version of the files. You know it's in the backup. You don't want to stand up a whole new VM to access the files. You just want to access the file system from that VM. So on the local machine where you run this script, there are some requirements. The files that you're going to access from these network drives must generally be from the same OS and version. And that's just because the file systems can vary. Like the NTFS file system on the Windows VM from the backup could be different than the NTFS from the local operating system where you're accessing those files. And so within reason, like Windows 7, 8, and 10 are together, but if you get an older version of Windows, some versions, NTFS could be different enough that you wouldn't be able to access that data. For Linux, the rule's similar in a way. The files must be from the same distribution type. Let me show you how this looks. If I go back to my VM, so I'll scroll down to backup, and these items at the top, I can restore the VM. So to restore a VM, you select a restore point. I have one, I'll choose that. And then create new. If you create new, your choices are create a new VM, in which case you enter the VM name and information like what VNet and subnet it's going to live on. You need a staging location in all these options. This is where it's going to store the disks as it's pulling them out of the backup before they're used by the VM. It's a temporary location. Under restore type, you could also choose restore disks. So this is the case where it pulls out VHD files, creates those as resources in Azure, and you could use those to build a new VM. So both of those are restore config of create new. Replace existing. Notice what it does is it's going to create a new VM. It doesn't ask you the name or anything because it's going to replace the existing VM. All you need to really specify there is a staging location. Last, under file recovery, you pick a restore point, and then you download this executable to run on the client machine. It mounts the drives across the network or across the internet to Azure. And then you just access them as they are network map drives. When you're done with those, you can unmount them here or Azure will do it for you. To complete this section, let's talk about some of the backup reports available. The summary data is viewed in the backup jobs in the portal. I showed you that a moment ago. This just shows you just a running list of jobs, their times, whether they completed or failed. Other reports can be seen in backup reports. I'll show you that in the portal. If I go to my vault, backup reports are under Manage, and there's a list of them here. I don't have any interesting reports because I don't have a lot of VMs and I haven't been running backup for any length of time. So I've got some screenshots I took from Azure documentation. The in-depth reports do require a Log Analytics workspace. Again, we will discuss the Log Analytics workspace in lesson 11. You usually need to enable diagnostic settings for backup and send that to the workspace. So in the Vault, you go to the Diagnostic Settings tab and enable the settings so that the Vault will send the data to the workspace. As for reports themselves, there's a summary report which just shows you these metrics. How many items are we backing up? How many VMs are protected? How much storage space are we using? Things like that. There's a backup instances report, which does have some summary metrics, and then also shows you a graph of how many backup items we have over time. So in a large environment with maybe dozens or hundreds of VMs, seeing a graph like this could be helpful in terms of knowing whether things are continuing to work as planned or not. There's a usage report, which gives you summaries of the different kinds of backups you're running. So here's Azure VMs that are being backed up. Here's SQL in an Azure VM. Here's Azure file storage that are Azure file shares we're backing up, which are none in this case. So usage report just is the kinds of things you're backing up. Jobs report is a nice summary of whether jobs are succeeding or failing. Color-coded, so any red could be a warning sign that you need to look a little deeper into what might be going on. So you might want to review some of the reports as well for backups in case you have exam questions about that. So backing up a VM to an Azure Vault, it's a good thing to do just in general, because it allows you to do recovery on that VM, but that recovery process can take time and it takes you back in time to the point the backup was taken. Azure Site Recovery is another resource you can use in Recovery Services Vault. They provide extra protection, particularly for critical VMs in production. Essentially, it sets up what's called, or what I would call, a warm standby copy of your VM. And then every few seconds, it takes changes from the disks of that VM and replicates those to copies of those VHDs that are stored in the Site Recovery Vault. This also uses the same kind of Recovery Services Vault that is used for backup, with one important difference. When you set up replication or site recovery for an Azure VM, the vault must be in a different region from the VM. Also, it must be in a different resource group from the VM. The reason that this is enforced is because if a whole Azure region goes out and your vault and VM are in the same region, then you're not really protected. So the rule or the requirement that you have to put the VM you have to put the vault in a different region than the VM protects you from regional outage. Different replication scenarios, we'll discuss some details of these in a little bit. Azure VMs can be replicated from one region to another. So maybe you have a critical VM in Azure and you want to make sure that if an Azure region goes down or that server goes down, that you can bring up the other server quickly in a different region. You might have on-prem servers, either Hyper-V or VMware VMs. and you could replicate those to VMs in Azure. You can also set up replication from on-prem VMs to a secondary on-prem site. In that case, you're just using the Azure Recovery Services Vault as a storage place for those VHD files. In the Vault, you can also create what's called a recovery plan. That's probably a good term for you to know. So site recovery typically is set up for a single VM, but if you have servers that depend on each other, you may need them to fail over together. If one fails, it may be necessary to fail over other VMs. You set up a recovery plan. You list the VMs that are being replicated that are part of that plan, and then you can also indicate what order those VMs need to be brought up in should a failover be necessary. Let me show you how to create replication for an Azure VM. So I'm looking at my VM, VM1, down under Operations. Here's Disaster Recovery. The terminology here is a bit confusing, I agree. So site recovery is one thing they call it. Replication is another, because replication is kind of the process that's used for creating this VM that you could do site recovery for. And the disaster recovery is another term that's used here, means more or less the same thing. If a disaster happens, I need to be able to recover this site or VM somewhere else. So if you're going to set up site recovery for your VM, you need to pick your target region. My VM is in East US. I have a vault in West US 2, so I'm going to choose West US 2. So you'd note that when I finish this setup, my VHD files will be replicated to the secondary region. Under Advanced Settings, in order to create the replication, Azure pre-creates some other resources. It needs to create a resource group, a virtual network, and perhaps some other settings. So why a virtual network? Well, a VM has to live on a virtual network. And since we want to protect ourselves from regional outage, the replicated VM should be in a different region than the source VM. So you need to have a VNet in the target or replicated VM. So by default, Azure just adds some characters to the end of the VM names. You can control that here if you'd rather have specific names. You can choose availability sets or zones if you need to. Under replication settings, you'll see that it's chosen my vault in West US 2. And if I like these details, I can start replication. This takes a while to establish. When it's finished, I'll show you some of the process for failover. In the meantime, let's talk about some of the scenario details. So if you're doing replication from an Azure VM to another Azure VM, there's a VM extension that Azure installs, and it's actually what copies the data to a cache. So it copies the changes to the VM VHD files to a local cache in the source environment, in the source region. And then that cache data is moved to disks that are in the target region. So in my case, my VM is in East US. I'm replicating to West US 2. So in this target region, those VHD files are going to be kept up to date. Notice also the VNet and the subnet are pre-created. They're empty because the VM doesn't exist yet. But when needed, I can easily put a VM on top of these VHD files. They'll be brought up, or it'll be brought up in this VNet. If you're doing on-prem Hyper-V to Azure, there's a couple of components you should probably be aware of. The site recovery provider is the thing that orchestrates replication. You can see that in this picture here, the Azure Site Recovery Provider. So it orchestrates replication. It sets up credentialing with the vault, also helps with replication and failover if needed. The data that changes is actually copied up with what's called the Site Recovery Services agent. So there's an agent that runs in the Hyper-V environment, and it talks to the vault to replicate changes to the VHD files. Notice in both of these cases, these components talk over port 443. So that means you don't have to punch any holes in your firewall. It's just going to use regular internet encrypted protocols to copy data up to your vault. The setup for VMware is a bit different. The components here, the first is called config server. So the config server is the component that orchestrates replication. The process server is the thing that copies data to Azure. So you can see in this diagram, the process and config server are combined on the same box or on the same VM, but those are two separate roles. There's also a thing called mobility service. So it runs as an agent, like a background service, on the VMs that need to be replicated in the VMware environment. And it collects those changes, gets them to the process server copies those up to Azure, again over port 443. There's another component called the master target, which can be used for failback. Okay, I'm back in the Azure portal. I'm looking at VM1. Let's see what the status of replication is. I go down to Disaster Recovery Blade. I can see that replication is in progress. It hasn't finished yet. It'll update progress as it goes. While we're waiting for this, let's talk about the steps for a failover. So the failover process, good idea after replication is established to first do a test failover. You should do that initially. You should also do it on a regular basis. Azure even warns you if you haven't done a test failover in the last 6 months. So the failover is a process that you begin if the source VM becomes unavailable for whatever reason. Maybe it crashes, maybe the Azure region goes out, maybe you have corruption for some applications or data on the machine. So in a case like that, you come to the portal, you initiate a failover process, and if the source VM is still available, then Azure will capture the latest changes from the source VM to the target environment. And that way you get a nice clean failover. In that case, then, to finish up failover, what Azure does is create a VM that sits on top of those disks that it's replicated, puts it on the subnet and VNet you've already specified. And if things look good, you commit the process. So you get back in the portal, there's a commit button, you press that button, and it sort of finalizes the changes. You might, as part of the commit, shut down the source VM as well. It might not be possible to capture the latest changes if the source VM crashed. So in a case like that, you can still do a failover and it'll just capture the latest VHDs that it has for that VM. They'll be, maybe a couple of minutes behind, but a lot better than restoring a backup. One thing you ought to consider too, after you commit, now you have the VM running in your target environment. There's no automatic replication back anywhere else. So if this is a mission critical VM, you might need to reprotect. So that's the word they use in the portal to set up replication for your target environment for another target environment. In the meantime, you can figure out what happened to your source VM, or perhaps wait for the Azure region to come back online or something like that. But in the meantime, you might need to have replication set up again through this reprotect process. Okay, my replication has finished. Let's see what it looks like. Here's my virtual machine. I'll look in the disaster recovery blade. And you can see that my replication health listed as healthy and protected. There's my recovery point objective, RPO. So that's how long ago the changes on the VMs were replicated to my target VHD files. No issues, everything looks good except I haven't done a test failover. You could do a test failover here. You could also start a failover process here as well. The failover process, it already knows what the source VM it is. It knows what the target VM is because I've already set that up in replication. It's warning here I haven't done a test failover in the last 6 months, but I can continue if I want. Here are my source and destination zones, latest recovery point. The shutdown here would be useful because if the machine's still available, because it would replicate the last changes. After that process is finished, you wait for that VM to come up, take a few minutes, and then you come back here in the portal and commit the failover. After that's done, as I said before, you may want to re-protect the new VM. So if you're having a really, really unlucky day and the failover VM also fails, then you have a process in place to bring it up yet another location. Welcome to Lesson 9, Configure Load Balancing, where we look at 2 of Azure's important services for handling large traffic volume for cloud-based applications. We first examine Azure Load Balancer, suitable for infrastructure deployments on VMs. We then discuss Application Gateway, a more flexible and full-featured load balancer for HTTP-based applications. Azure has a few load balancing services, and there's 2 of them you're responsible for on your exam. The first is called Azure Load Balancer. It's a general purpose load balancer that's good for VM workloads. It needs to be created in the same region as VMs or a VM scale set that you put in what's called the backend pool, as we'll talk about soon. It operates at network layer 4, which means it looks at the source IP and port and destination IP and port, along with the protocol to determine how to do routing. So typically for load balancers, you might load balance port 80 or port 443, perhaps a custom port depending on the application. When you set up a load balancer, there's a few choices you need to know and choose at the outset. The first is whether you want a public load balancer. It has a public IP address, so it's going to map incoming requests from the internet. A good example of that would be a public-facing web app, like you see here in this picture. The other kind of load balancer is called an internal load balancer. It has a private IP address, not a public IP address. It also distributes traffic the same way for VMs on a VNet. It could be used for maybe an internal web service, something like that that you need to support a business tier in an internal application. You also have to choose what's called a SKU, or kind of a tier when you set up a load balancer. So the basic SKU has a few rules. The VMs in a basic SKU need to be standalone VMs or in the same availability set or in a single scale set. They also must reside on a single VNet, and the same VNet, or the region where your load balancer is established. You can have up to 300 VMs in the basic SKU. For standard SKU, you can use any number of VMs or multiple VM scale sets. They can be in different availability sets, all on the same VNet still, but up to 1,000 VMs. So standard SKU supports more VMs in the backend pool. If you put a public IP address on your load balancer, it must match the SKU of the IP address. So public IP addresses in Azure come in basic and standard as well. So the basic public IP has features that work for a basic SKU load balancer. Standard public IPs work for standard SKU load balancers. If you set up your load balancer in the portal works this out and makes the right choices for you. If you don't have a public IP for your load balancer, if it's an internal load balancer, then you can use either SKU for private IPs, not necessary. After you set up a load balancer, There's some configuration that needs to be done. First is to set up a backend pool. So the backend pool is where the VMs or the VM scale set live that are going to be balanced for the load by the load balancer. All backend pool instances must be in the same region. A health probe is created next. So this is used to determine the health of each VM or VM scale set in the backend pool. Unhealthy instances are not sent incoming requests. So the load balancer sends requests via the health probe every few seconds to each VM in the backend pool, and anyone that doesn't respond is taken out of the cycle for a time. The load balancer then keeps checking with that VM. As soon as it's healthy again, it'll put it automatically back into the pool. After you set up a backend pool and a health probe, you can configure a load balancing rule. So a load balancing rule is just how load balancer is going to distribute this traffic. An incoming request on port 80 or 443 to the front-end IP address could easily have a rule that says, oh, just map that to any VM that's available in the backend pool, perhaps even on the same port. So if it's port 80 or port 443, then these VMs would be running, let's say, IIS, and they'd be listening on those ports. And so any VM could accept any one of these requests and reply. When you set up a load balancing rule, you have to choose your backend pool and you have to choose a health probe, which is why you set those up first. One other thing you can optionally configure for a load balancer is what's called an inbound NAT rule. So most incoming requests to a load balancer come from customers or users, and you would want any backend pool VM to take the request and process it. However, sometimes administrators need to connect to a specific VM, perhaps for configuration. And so an inbound NAT rule allows you to map front-end information, IP address and port, to a specific VM, to a specific IP and VM and port. Let me show you how to set one of these up in the portal. If I go and look for load balancer, it doesn't show up in this short list, but if you hit enter here, you'll see it's one of the first items. So this is the load balancer Azure provides. And in the creation of it, you need to specify typical things up front, plus the name of the load balancer in the region, and then here's your SKU information. So it could be standard SKU. Standard SKU supports public and internal, and the tier can be either regional or global. So global is a relatively new tier, which allows you to support VMs that could be in different regions. The basic tier only supports regional load balancers and not global. You must also provide a front-end IP config. Let me just choose a resource group here. And the front-end IP config is the front-end IP address of the load balancer. The rest of the items, backend pools, inbound rules, and others, are optional. They can be configured after the fact. I've created a load balancer. Let's go and look at it. So here's my load balancer. It's got a front-end IP. That's a public IP address. I've defined a backend pool. My backend pool is made up of virtual machines. And I added one, my VM, VM1. So VM1 is the VM in my backend pool. Typically, of course, you would add multiple VMs. That's why you would set up a load balancer to begin with. There's reference here to the rule. I can show you that here too in a moment. So health probes I also need to set up, and I've got one health probe. So notice my health probe says, on port 80, contact the VMs in the backend pool and every 5 seconds. And if you fail to get a response twice, then mark this as an unhealthy VM. And then keep checking with it every 5 seconds. When it comes back and is ready and available, then start sending it requests again. So if you have the front-end IP and the back-end pool and health probe established, then a load balancing rule is possible. So here's my load balancing rule. My rule says if a request comes in to the front-end IP address, then send it to the back-end pool. Inbound port is 443. The back-end port for the VM is 443 as well. Use this health probe, which I've established, and you can decide about session persistence. So session persistence allows you to make sure that subsequent requests from the same client get sent to the same VM in the backend pool. That can cut down a little bit on throughput, but some applications might require that depending on how they're written. So setting up a load balancer, there's several steps involved, but it's fairly straightforward. If you want an inbound NAT rule, you can also specify those here. I have one NAT rule which says if a request comes into the front-end IP on this custom port, so 33891 is just a port I decided to make up, then pass it to the backend's VM on port 3389, which is the RDP port. So in this particular case, I've got port 33891 on an inbound request, and I want to target VM1. And when I send the request to VM1, I want to use 3389 because VM1 will be listening on that port for RDP requests. So to summarize load balancers, let's compare the SKUs a little bit. Basic supports up to 300 VMs in the backend pool, while standard supports 1,000. Backend pool instances for Basic have to be VMs in a single availability set or a single VM scale set. For standard, it's a little more flexible. You can have any VMs or multiple VM scale sets as long as they're on one VNet. Notice there's a health probe difference too. So standard is the only one that supports HTTPS health probes. Default access for Basic is open into the internet. For standard, there's an NSG built in. You can customize that if you need to. The other options here are available only for standard high availability ports, availability zones, and outbound rules. So if your exam question is which kind of load balancer to use, you might study this chart, also look back at the lecture and see some of the differences in load balancers to determine which one would be appropriate. The other load balancer we want to talk about is Azure Application Gateway. This is a global load balancer good for web apps or web services. It's a little more flexible in that the backend pool can support multiple kinds of hosts, VMs, VM scale sets, also web apps, or even just a general IP address. It operates at network layer 7. That's the application layer, and particularly the application protocol it understands as HTTP or HTTPS. Those are the only protocols it understands. So if your exam question, let's say, were to talk about needing to load balance something that was not HTTP or HTTPS, then you could not use an application gateway. You'd have to use a standard load balancer. We'll see that there's some nice advantages to working at the HTTP layer. In the general drawing, you can see that this load balancer looks like or operates more or less like a regular load balancer. It's got a front-end IP address. It's got a listener, which is listening on particular IP address and port, and then it has rules, and the rules establish how to map to backend pools. Some features of App Gateway which make it a nice choice. There's multi-site hosting. So this allows you to host multiple applications behind one App Gateway. Since Application Gateway looks at the HTTP request, it can look at the URL requested in the request for HTTP. And the DNS name, like contoso.com or fabricom.com, could be used to determine where to map the request in backend pools. Another feature of Application Gateway that's related to that is URL path-based routing. So again, since we can look at the URL for the incoming request, in HTTP, then if the URL contains a folder or path that, let's say, has images as part of its name, then you can have Application Gateway map that to an image pool. Whereas if it contains video, you could map it to a different set of VMs for a video pool. So it's nice to be able to look at the HTTP request to determine information from the URL that can make the routing smarter. Another feature is what's called TLS termination or TLS offloading. So in that, App Gateway decrypts the incoming request that would be encrypted using TLS, and then it sends the unencrypted request to the backend server. The server responds to Application Gateway, and then App Gateway can encrypt it using the same TLS certificate and send it back to the client. This can just save you capacity on servers in the backend pool because they don't have to decrypt and then encrypt requests and responses. Another feature is HTTP redirection. So if you have an incoming request and the user didn't put an S on your HTTP URL, then you can have App Gateway automatically send back a 301 redirect response. The client browser picks that up, uses HTTPS, can communicate with App Gateway to figure out how to do encryption, and then just saves time and capacity on your backend servers as well. The last feature I want to mention, you can choose this when you set up your Application Gateway. It's what's called Web Application Firewall, or WAF, W-A-F. This is a different tier of App Gateway, and it provides some additional services at the App Gateway which protect web apps from common exploits. So cross-site scripting attacks or SQL injection attacks can be detected at the App Gateway rather than passing those back to servers in the backend pool. So when you set up an Application Gateway, which I'll do in the portal in just a moment, there's a couple of tiers. There are V2 tiers, and those are recommended because they just contain more features than the original tiers for Standard and WAF. So Microsoft recommends Standard V2 and WAF V2. You must have a VNet chosen when you set up Application Gateway, and you have to deploy it to an empty subnet. So the subnet is used by Application Gateway to be able to create multiple instances if they're needed. You must also set up a front-end IP address. You have to have at least one public IP for your Application Gateway. You can also additionally have a private IP if you want to support that or need to support that for applications. Your backend pool, as I mentioned before, is pretty flexible. It can be VMs, VM scale sets, even Azure App Service, a general IP address, which could be really located anywhere on the internet, or even a domain name. And then the routing rules you also set up when you create your Application Gateway. And so it's good to think ahead if you want to support multiple applications behind App Gateway for multi-site hosting, or perhaps for path-based routing. Let me show you how to set one of these up in the portal. We'll talk about its configuration as we go. So I'm in the marketplace. Look for Application Gateway. I'm going to create one. I'll create a new resource group. Let's see, I should have a resource group here too. I'll use this resource group. I'm going to call this Gateway 2. I'm going to put it in East US. My tier, notice the choices here, Standard and Standard V2, and then this would turn on Web Application Firewall for additional cost. Do you want to enable auto scaling? That's a feature of the V2 tier. So auto scaling means that if your Application Gateway gets very busy, Azure will automatically add an instance of your Application Gateway to support your backend pools. You could also turn that off if you don't need it. And then you do need to have a virtual network established here with a subnet that's empty. I have an empty subnet app GW. I need to specify a front-end IP. I'll add a new one. Specify a backend pool. So my target types here, here's where you can choose an IP address or domain name, a VM, a scale set, even an app service. So I have an Azure app service, I can pick that here. You would typically have multiple things in your backend pool. So I have a front-end IP called public. I have a backend pool established. I now need to add at least one routing rule. So a listener is what listens at an IP address and port. I'll call this listener 1. My front-end IP is established. That's public, which is here. What protocol and port am I listening on? Is this a basic or multi-site in case I was going to map this to multiple sites? And then I need to fill out backend targets as well. So I'm going to choose a backend pool, which is, there's my pool. I need to add what's called HTTP settings. And this establishes things like, do I want cookie-based affinity so that multiple requests from a user are sent to the same backend server? Do I want a drain connection over time so that I can consolidate requests into fewer servers? What kind of a timeout do I want for requests? Do I need to map host names differently? I'll leave all those as defaults and just click Add. Now I'm ready to add my routing rule. I'm done with configuration here. I can review and create, and Azure will set up my application gateway. While that's working, I'll show you I have another application gateway established already. Gateway 1. And you can see that the blades in here follow much of what we saw in the marketplace when I was setting up Gateway 2. There's the tier, instance counts, I had autoscale turned on for that. Web app firewall is turned off here. I could turn it on. There's my backend pool. My backend pool has one app service in it. HTTP settings, my front-end IP. I have one public IP. I don't have a private IP configured. I have one listener listening on port 80 that's going to map to rule 1, which says send those requests to the backend pool. So App Gateway is another viable choice for web applications if you're deploying those in Azure. So in this lesson, we have talked about two of Azure's load balancers. One was called Azure Load Balancer. General Purpose Load Balancer operates at the TCP layer, so it understands IP address and port. It does not understand anything about the HTTP URL. It has backend pool, a health probe, and a combination of those can create a load balancing rule which maps source IP and port to destination IP and port. We also looked at Azure Application Gateway. It operates at the application layer, specifically HTTP or HTTPS. It has additional features it supports because of that: multi-site hosting, URL path routing, and even TLS termination. You use the special tier of Application Gateway called Web Application Firewall if you want additional protection for your applications. Let's look at a couple of the command line highlights. So in PowerShell, under Load Balancer, here's new AZ Load Balancer, all spelled out as you might expect. Here's new AZ Load Balancer backend address pool. So it creates a backend pool. Also for adding rules, we go up to Add, You can add a new rule. There's a NAT rule config you can create, how to add the front-end IP config. So add, as often in PowerShell, is used to enhance or set properties of a resource that you have created. For the CLI, the clue is to realize that all of the load balance features are under AZ network. So you have to find the AZ network command first, and then there you can look for things like AZ network. Load balancer is called LB. So notice the abbreviation specifically there. So under AZ network LB, you'll find the create. There's create, that's address pool create. This is how to add the load balancer itself. And then managing backend pools, managing health probes and things like that would be under LB as we keep going. If you are looking for application gateway, it's not abbreviated, it's all spelled out. So application-gateway, you can see here how you create the application gateway. You set up the address pool with a create. So a little tricky for differences in LB versus application gateway, but that's the idea. Welcome to Lesson 10, Manage Azure Networking Services. In this lesson, we take a look at some of the common services used to support VM deployments in Azure. First up is Azure DNS for both public and private hostname resolution. Next, we examine Azure Bastion, a service for secure administrative access to Azure VMs. Then we discuss Azure Firewall, a managed, scalable firewall to protect VMs. And finally, we finish by looking at Azure Virtual WAN, used to connect widely distributed on-prem sites and Azure VNets into a private internetwork. DNS is a service we're all familiar with. On the internet, it translates a friendly computer name or domain name into an IP address. It's really just a global network of zones, and zones are managed by people who own DNS names so that they can put in the relevant IP addresses for their own hosts or servers that they manage. Azure allows you to create DNS zones to manage host names in Azure as well. This is very convenient if you have several Azure VMs because you're already managing your VMs in Azure. Perhaps you just want to manage your DNS names for those VMs in Azure as well. It's optional, you don't have to do this, but it can be a nice convenience. You can set up public DNS zones, and so those will actually hook into DNS that's used on the internet and to resolve host names for publicly deployed applications. You can also set up private DNS zones in Azure, and those resolve host names on a VNet, typically used by VMs on a VNet to resolve host names. Setting up an Azure DNS zone is fairly simple. You should own the domain you want to host. When you do, you go to the Azure Marketplace, you create an Azure DNS zone, which I'll do in just a moment. And then you need to go to the domain registrar for that domain and delegate the zone to Azure DNS. This changes what's known as the name server records, the NS records at the parent domain, to point to Azure. And that's what will actually hook in your Azure DNS zone into global DNS. You can also subdelegate, which means to create a subdomain under a domain name that you own. So if you own acmeparts.com and you set up a DNS zone in Azure for acmeparts.com, you could set up a second zone for sales.acmeparts.com. And this is called subdelegation, and it's an extension of DNS zones. After you set up the zone and you delegate to Azure, then you populate the zone by adding zone records. There are several types of zone records supported by Azure DNS zones. A records are probably the most common. Those map a host name or friendly name to an IP address. CNAME records map a host name to another host name. So that implies there'll be another lookup, but it's a nice indirection for hosts that might need multiple host names for a single IP address. PTR records, pointer records as they're also called, maps reverse lookup, so IP address back to host name. There are other record types supported, as you see here. You might use these in some of your travels too, like MX records for mail lookup. Even TXT and pointer records are used by certain services. You also specify a time to live when you set up new records. That determines how long the client will hang on to that IP address before it throws it away and comes back to the DNS zone and asks for an updated IP. Let me show you how to set one of these up in the marketplace. So I'm in the marketplace, I'll look for DNS zone. Notice two choices here. This would be a public DNS zone. This would be a private DNS zone, which we'll cover later. So here's DNS zone. Very simple to create. I'll set up a new resource group. For name here, you want to list the DNS name that you own. Resource group location, I want this to be in East US. That's all I need to set up my zone. I can review and create. And next I'll add a couple of records. Okay, my zone is complete. Here's my acmeparts.com. So I do not own acmeparts.com. Azure allows me to set up the DNS zone, but realize nobody's pointing to this. The internet doesn't know about this zone and will never know about it unless I go to my domain registrar and add these name server records. So these NS records are the ones you would put in your domain registrar who helps you manage that domain name. And then your registrar would delegate over to this domain in Azure. The primary thing you would do after setting up a public DNS zone like this is to create a record set. So notice acmeparts.com is the suffix. I'm just going to put in the name of a server. Server 1. I want to create what kind of record type? Let's say an A record. You could set up record sets as well, which is possibly multiple IPs that are round robin through for DNS resolution. I'll leave that as off. My time to live is 1 hour. You can change that if you like. And you just need an IP address. So that's about all there is to set up a zone and add record sets to it. So you can see how easy this is to set up in the portal. Let's talk about managing private DNS zones in Azure. So when would you need a private DNS zone? This is not used on the internet. Instead, it's used on your VNets. Provides DNS resolution on your VNets. You might remember when we discussed VNets, I said that on a VNet, Azure will find other private IPs on that VNet. So it'll find hosts by IP address. And it'll even do name resolution on a VNet for private IPs. But that's sort of a convenience for you. If you peer VNets, so if you have more than one VNet, if you have multiple VNets and they're peered together, there is no DNS resolution across those VNets provided by default. An easy solution is just for you to set up a private DNS zone. Once you do this, you can link your VNets to a zone, and then Azure, as it manages your VNet, will use the DNS zone to help resolve IP addresses. In this picture here, you can see that a VM on a VNet is going to just put out a request on the VNet for how do I get the IP address of this particular DNS name. And the private DNS zone responds with the IP address, and then I can just connect via IP. One other feature of private DNS zones as well, you can enable what's called auto registration. When you do this, then VMs that are booted on the VNet, Azure assigns the IP address, right? I talked about that in the VNet section. So when an Azure VM is booted, the VNet assigns an IP address that's available from its IP address space. If you turn on auto registration, Azure will also then pass that IP address to the private DNS zone for that VNet. This is a very nice feature because it means you probably don't have to populate your private DNS zone. Azure will just manage it for you. To set this up, go to the marketplace, create a private DNS zone. No delegations necessary because this doesn't have to hook into global DNS. Add any VNet links that you want. So these would be VNets that you want to use this zone for DNS resolution. Enable auto registration for each link if you like. There is a rule that for a VM that's multi-NICed, so if the VM has multiple network interfaces, only the dynamic and primary NIC for the VM is registered, right? So if you have the secondary NICs are not registered automatically, and static IPs are not registered, only dynamic. I mean, the static IPs you could add to the zone if you wanted to. Let me show you how to set this up in the marketplace. I'll look up DNS zone again. Here's private DNS zone. So a resource group, I could choose existing or create new. This again is a domain name. You could use acmeparts.com again because this is private. I'll just use a different one to cut down on confusion. And notice that's all I have to do to create this zone. When it's done, I'll show you how to link VNets. So my zone is done. Let's go have a look. Notice you can add record sets here, just like I did for the public zone. This is the same kind of setup. Basically, the same kind of records are supported. But perhaps more importantly, what you would do is set up a VNet link. So I can add a link here. I'll call this my East link. And it looks in my subscription for VNets. I can choose VNet East or East VNet. I can enable auto registration, click OK. And then Azure will do most of the work of populating my private DNS zone. One final thing to note, a VNet can override Azure DNS. I'll show you where you find that in the portal. It's shown here in this screen grab. So you can, by default, you use the DNS servers that Azure provides, and that's going to be the one where auto registration happens and where your VNet links are working. But you can change that if you wish. So back in the portal, here's the virtual network link I set up for acmeparts.hq. I can just click through the link here to get to my VNet. Now I'm looking at VNet. If I look down in this list, here's DNS servers, and notice that I'm using the default Azure provided servers. If I overrode that here, then it would ignore the DNS private zone settings for this particular VNet. One final thing to note here is importing and exporting zone records. So the Azure CLI has commands for importing and exporting zones. There are no PowerShell equivalents for these commands, so it's only supported in the Azure CLI. The files are text files, and they're in a standard DNS format. This can help you populate a zone, particularly a public zone, when you first set it up. For a private DNS zone, the CLI command AZ network private-DNS zone import. You specify the resource group, the domain name, and the text file. Also the same for export. For public DNS zone, it's very similar, except instead of private-DNS, you just have DNS. Azure Bastion is a service that permits secure admin connections to your VMs. It's a virtual appliance that you deploy on a VNet, and it acts like a jump host. What that allows is for people outside of Azure to connect through Azure Bastion to a VM that's deployed in Azure on a VNet. This eliminates the need for public IPs on VMs. So if you have VMs deployed to Azure and they don't need to have a public IP address, but you put one there just so you could connect to it over RDP, then you could remove that public IP and access the VM through Azure Bastion service. This also works for peered VNets. So you might just need one Azure Bastion service set up to potentially connect to any VM that you have deployed in Azure. To set this up, you need to have a subnet on a VNet, and it must be called Azure Bastion Subnet. So create a new empty subnet called Azure Bastion Subnet. It needs to have a network prefix that's 27 bits or smaller. You then assign a public IP to Bastion so that you can access it from outside. And then you use the Bastion blade in the portal just to connect to the VM. I'll show you how this works. So here's a VM I have, VM1. Notice on the networking blade, I do have a public IP for this, and maybe I need the public IP because I'm running a web app. But notice I also have port RDP open, 3389. And I did that so I could log onto the VM over that public IP, but I could remove that port assignment in the network security group. And when that's finished, I would need to use Bastion to access the VM. So how do I do that? Same VM, I scroll down to the Bastion blade. I've already finished step 1 here. I just need to have enough IPs available. Step 2 is create an Azure Bastion subnet. So the portal will create one for me. It's chosen an appropriate address space. I'll leave off the network security group. I'll just have the portal create my necessary subnet. And then step 3, I need to set up Bastion. The portal has filled in most of the choices I need here. It's creating a Bastion instance, and it's just given a name to that that's based on my VNet. Chosen a tier of standard. There's standard and basic. An instance count is just how many instances of the Bastion service do I think I need. I need a public IP for access to a Bastion. It's going to create one of those for me. I'll click Create here. When that's done, I will show you how to log onto the VM using Bastion. So Bastion has been set up, and you see the Bastion blade here for the VM now just shows boxes where I can enter credentials for logging on. If I know the admin credentials for logging on to that VM, I can log on. Now, this uses an in-browser projection. So it's accessing RDP, it's going to project the desktop from that VM, but through the web browser. So you see it's just a separate browser tab in my web browser. First time I've logged onto this VM, so it launches Server Manager. So a much more secure way to manage access to VMs in Azure without having to open ports in network security groups, perhaps even not having to create public IP addresses for your VMs. Azure Firewall is a firewall as a service that you can deploy to a VNet in Azure. You could certainly set up a VM yourself and install some firewall software on it and use that to protect VMs you have deployed. But Azure Firewall is a virtual appliance. It's a managed service. It'll do many of the features of firewalls once you set it up and configure it, and you don't have to maintain the VM that runs the firewall. It has threat intelligence that's built in, so it watches for certain kinds of threats. You can either alert or alert and deny. So an alert allows you just to be notified as an admin that a threat has occurred. Alert and deny can even stop the traffic. Microsoft uses, it's the intelligence it has about known bad IP addresses and domain names to help protect, and it updates those on a regular basis. This firewall as a service also has built-in availability and scalability, so it'll automatically scale itself up if you get enough traffic and you need more capacity. In this picture, you can see that Azure Firewall is deployed in Azure, and it's protecting these VNets that we connect to the Azure Firewall VNet. You can also use Azure Firewall to connect to on-prem networks. If you're talking about Azure Firewall, these days you'll also end up talking about what's called Firewall Manager Policy. So policy is a set of rules that help you determine or help Azure Firewall determine what traffic is allowed in or out. And actually, technically, these rules are made up of rule collections. So a rule collection is just one or more rules at the same priority. And there are different kinds of rule collections. You can have network rules. Network rules allow or deny traffic by IP or an IP group. Could also allow or deny by service tag, which is like an Azure type of service, or a domain name. Notice that network rules are evaluated first in any kind of policy. Application rules are evaluated next, and they allow or deny traffic by protocol. Application protocols, currently the only supported applications, are HTTP or HTTPS and MS SQL used by Microsoft SQL Server. A third kind of rule collection is what's called a DNAT rule collection. So these allow inbound access, typically for VM configuration. Think RDP or SSH here, because you might want to allow inbound traffic from outside of Azure to configure a VM that's behind the firewall. So when you set up a firewall manager policy, you establish these rule collections, carefully selecting your priorities so that the rules are evaluated in the right order. When a rule match occurs, it terminates the search, and then either that packet is allowed or denied based on what the rule says. Another nice feature of Azure Firewall Manager policies is that you can use the same policy on different VNets. So you can build a hierarchy of policies for your organization. Rules are inherited from the parent policy, and the parent rules take priority. In the diagram you see here, there's an organization-based policy that's been established that has a set of rules that may allow or deny certain kinds of traffic, but then different policies can be applied or created for different kinds of workloads you might deploy in Azure, say for sales or for engineering. Having these policies as separate from the actual firewall makes it easy to reuse them in different situations. So you can organize your policies and then just apply them as needed in different parts of your deployed infrastructure. We also need to talk about Azure Firewall Manager. So Azure Firewall Manager is sort of the central location in the portal where you're going to set up and manage policies and then manage connections for VNets and possibly even on-prem resources. I'll show you Azure Firewall Policy in the portal in a moment, but when you set up these hubs that interconnect VNets and on-prem resources, there's two hub types. One is called a hub VNet, Hub Virtual Network. And this architecture has an Azure Firewall deployed to a VNet that you would consider the hub VNet. You can then create other VNets and peer them together. Typically, you would peer the spoke VNets to the hub VNet to generate a hub and spoke architecture. Since Azure Firewall is on the central hub VNet, then it can provide protection for all the peered spoke VNets that are behind it. The other kind of architecture is called a secured virtual hub or secured vHub architecture. Instead of an Azure Firewall as a central component, it has a virtual WAN hub as a central component, but a virtual WAN hub that has Azure Firewall Manager policies associated with it. We'll talk about the virtual WAN hub later in this lesson. This is for larger deployments, maybe for organizations who have VNets deployed around the country or the globe, and you want to be able to connect all your VNets together, maybe VNets to on-prem resources, maybe VNets to the internet, even on-prem resources to the internet. I'll show you an example of that in a moment. What I want to do now is go to the portal and look at Azure Firewall Manager. So Azure Firewall Manager is not on menus by default. You can find it from the search box. Here's Firewall Manager. You can also manage policies here and Azure firewalls themselves, but the Firewall Manager is designed to be the central location where you can create and manage all these things. When you come into Firewall Manager, you see that there's a list of virtual networks that you have hooked to an Azure Firewall, a list of virtual hubs that you might have set up. You can also manage Azure Firewall policies here, and so forth. So this is a central location, central place in the portal which you can use to manage this kind of firewall deployment. Let's start with an Azure Firewall policy. I've created a simple policy here called Policy 1. If I look at the policy, I can see a summary of the rules. So I'm imagining an environment where I have Azure Firewall deployed to a hub VNet, and I have some VMs behind it that need port 443 traffic to allow, because I've got some web services deployed. Also have some SQL databases deployed, so I'm going to allow SQL traffic. So I've set up two rule collections. The network rule collection port 443 is top priority at 100. The action is allow, and the information is any IP address inbound, so source of any, destination of port 443 for anything behind the Azure Firewall should be allowed in. I have a similar application rule collection for SQL that allows traffic from anywhere outside to MS SQL. So that's a specific protocol that's supported in Azure Firewall Manager policies. So the combination of these rules make up this policy. The policy itself can then be applied to various VNets. And I'll show you how to do that in a moment. Let's go back to Firewall Manager. After you set up one or more policies, you might want to set up a virtual network secured vHub. So I can create that here. So this is going to be a new VNet that's deployed to Azure. I'll call this my hub VNet. I need to pick an unused address range. That one's not used in my deployment currently. And then specify details of the Azure Firewall. So I need a new public IP address, an address space for a brand new subnet that's going to be created called Azure Firewall Subnet. So that subnet will be used by Azure Firewall on this VNet. We use standard tier, and I can take the policy I've created and apply it to this hub as it's created. Okay, my deployment's finished. Let's go look. Go back to Firewall Manager. You can see I have a new virtual VNet, a virtual network, a hub VNet. It's got policy 1 applied to it. To complete this configuration, I would need to go to East VNet and West VNet and peer each of them with hub VNet. That creates the hub and spoke architecture, and then the policy applied to hub VNet would prevent unwanted traffic on those other VNets. So you can see how Azure Firewall Manager is a central location to help you manage policies for Azure Firewall. Also VNets, hub and spoke VNet topologies, and even virtual WAN hubs, which we'll discuss in a moment. Here's a picture that shows an example of a deployment. On the right, you see an Azure Firewall deployed to a hub VNet. The other VNets that you see connected to this are spokes. So Azure Firewall is the central location, so the policies that are applied there can be enforced on the spoke VNets. There's also a connection, either ExpressRoute or VPN, to an on-prem data center. The other thing you can do in Azure Firewall Manager is set up a secured vHub. That's just to connect lots of different kinds of networks that you have, either VNets in Azure, maybe multiple branch offices that you have deployed around. And then finally, the policies that are established. The global policies can be shared across both of these kinds of resources, so it becomes much easier to manage them. To wrap up this section, let's talk about different firewall services. We discussed in Lesson 9 what's called Web Application Firewall. That's a platform solution. You can turn it on as part of Application Gateway that you set up. Also another service called Front Door. It has built-in capabilities for watching for certain kinds of attacks. It does allow some custom policies. Typically, it's put in front of Application Gateway. In this lesson, we've talked about Azure Firewall. So it's also a platform solution. It's a managed firewall. It's for protecting VNets and VMs. So that's a big difference here. App Gateway is a platform solution where you put web stuff. Azure Firewall you would use if you had VNets and VMs set up and you wanted a platform firewall that could be managed largely by Azure for scalability and availability and so forth. It uses Firewall Manager policies to manage the rules. And then Azure Firewall Manager, finally, is not actually a firewall, but it's a manager, right? So it's not a resource, it's just a place you can go in the portal to help you manage Azure Firewall and policies and so forth. The last topic in this lesson is Azure Virtual WAN. It is an internetwork of on-prem sites and Azure VNets. You can see here in the picture there are 2 virtual WAN hubs that are defined for this large organization, and they can be used to connect VNets in Azure. So the virtual WAN hub becomes a hub and your VNets can be spokes. And then notice also can easily connect up headquarters, on-prem sites, branch offices using ExpressRoute or site-to-site VPNs, even point-to-site VPNs for users who are accessing the resources from their own computer. So a virtual WAN is for large organizations that have, many VNets deployed perhaps globally in Azure and the need to hook up many branch sites. It can simplify the management of this. Routing across a virtual WAN hub is automatic and it uses the Azure backbone. So once you hook up your branch offices to the WAN hub, then your traffic is inside of Azure, and any connections to other kinds of resources like on VNets or even another hub, virtual WAN hub, use the Azure backbone for communication. To set one of these up, there's a few steps. First, you would create a virtual WAN resource. You can do that in the portal using the marketplace. I've created one from the marketplace. It's very simple to set up. It only requires a few things like a resource group and a region. And then this just becomes the place where you'll hook up these other elements that you want to connect to your virtual WAN. Next step would be to add a virtual hub. So once you have a virtual WAN resource, you set up the vHub. Microsoft manages this VNet, and this becomes the hub to which you'll connect all the other kinds of resources. After creating a virtual hub, you set up or identify other network resources you want to connect to the hub. It could be a site-to-site VPN, an express route connection, point-to-site VPN, could even be another VNet you have in Azure. And then you just simply connect that resource to the vHub. And so Virtual WAN Hub becomes a central place that makes it fairly easy to manage all this interconnectivity. So these are the steps for setting up a virtual WAN hub. I want to call out one thing terminology-wise. So the mention here of a virtual hub provides you that capability of the central VNet hub that other things can connect to. We also saw that when we were talking about Azure Firewall Manager. Back in the portal, you can see I've got Firewall Manager up, and there's a notion or mention of virtual hubs here. The difference here is if you set one of these up here, it's what's called a secured virtual hub. It's basically a virtual hub, like from Virtual WAN, but it uses Azure policies that you've established. So these resources are related, and if you wanted to use Azure Firewall Manager policies, I would suggest you create your hub from Azure Firewall Manager. To wrap up this lesson, let's remember that we talked about Azure DNS first. There are public DNS zones and private DNS zones, both of which you can manage in Azure. Public DNS zones hook into the DNS namespace on the internet. Private DNS zones are used internally for VMs, VNets in Azure that you might want name resolution for. We also talked about Azure Bastion, which is a way to secure access to your VMs. You deploy it to a VNet, and then you can access VMs on that VNet or other peered VNets without having to use open ports and public IP addresses on VMs. We discussed Azure Firewall, including firewall policies you set up through Azure Firewall Manager that contain all the rules, and then how you can hook those policies to vHubs and secured VNets in order to provide firewall management for your deployments in Azure. Last, we discussed Azure Virtual WAN, which is a way to set up an internetwork of VNets and on-prem sites you can manage through Azure's backbone. You can couple this with the security set up in Azure Firewall Manager in order to use both services, Firewall and Virtual WAN. Let's talk about command line highlights. In PowerShell for DNS, there are a couple of different choices in the entries. The first here, new AZ-DNS zone, this creates a public zone. And you can see the other commands here that are used for things after that. Setting up record sets or configuring a record set. For private DNS zones, it's new AZ private DNS zone config to set that up to begin with, and then you can add record groups to that as well. For firewall, let's look at AZ Firewall. In fact, let's look at new. AZ. So there's a section down here in the network section. This is for setting up a new firewall. And then after you get the Azure Firewall set up, you can create application rule collections, you can create network rule collections, establish new policies, add those rules to a policy. In the CLI, we'll again find that all of the items in this chapter are under AZ Network. So here's AZ Network DNS. So this is for managing DNS domains in Azure. There's also AZ Network Firewall. So you'll find similar kinds of rules here we saw for PowerShell that help you create the firewall and then manage all the policies and the rules that you might set up for it. Welcome to Lesson 11, Monitor Azure Resources. All mature Azure deployments need to be monitored, so in this lesson we look at the tools Azure provides to maintain resource health and security. We learn how to configure Azure Monitor, the main repository of log and metric data for Azure resources. We also discuss the tools built on Azure Monitor data, such as Azure Advisor and Application Insights, and how to use them to proactively manage your Azure environment. Monitoring is an important part of any Azure deployment. As you get resources in Azure, you will need to know over time how well they're performing. If they're underperforming, what you can do to solve problems that occur. You can capture monitoring data from most any kind of resource you set up in Azure, whether it's an infrastructure resource or a platform resource. They're captured in Azure Monitor in what are called metrics and logs, which I'll say more about in a moment. And then they can be analyzed and used. So you can graph the results, you can query the results, you can set up alerts based on things that are happening in metrics. You can stream the data to other applications or even to external APIs. So very mature environments will need to take advantage of this in order to keep your Azure deployment running smoothly. So metrics capture numeric telemetry data, and logs capture event and audit data. Let's look a little deeper at that. So metrics are captured in real time as you use the Azure resource. So your application, whether it's a platform resource or infrastructure resource, is running on Microsoft's infrastructure. And so it captures information about that resource. How busy is the CPU? What kind of network I/O are you generating? How many HTTP requests to your application? Metrics are kept for the last 93 days in a rolling window, so you can query across that time. The Metrics Explorer is the thing in the portal that you can use to generate graphs of these metrics. The picture you see here is a CPU percentage. So you see CPU percentage up to 100%, but the multiple colors here mean that we're looking at multiple VMs. So powerful way in the Metrics Explorer to generate graphs that show you information about multiple resources. Makes it very easy in the portal for you to be able to track your important VMs, how well are they performing. You can find the Metrics Explorer in the portal by looking at just about any resource. So here's a web app I have. If you scroll down in the web app, most resources have a monitoring section. Under monitoring, you'll find metrics. So I can select a metric here like CPU time for my web application, and I can see over the last 24 hours how busy it's been. I can change the information about the look of the graph. I could make it an area chart instead of a line chart. I could make it a bar chart or scatter grid. We'll talk about alerts later in this lesson. You could pin this to a dashboard. So as you log onto the portal, your dashboard can be shown as your home page, and you can easily see how your metrics look and whether your resources are performing as you expect. In addition to metrics, Azure Monitor captures logs. So logs are those running record of what happened when for most resources. So in a Windows VM, you might be familiar with the event logs, the system log, the application log. IIS has logs that capture the traffic that comes and goes through IIS. Also, there's insight logs. We'll see more about these later in the lesson as well. So certain kinds of applications like web apps have additional insights that you can easily see for your Azure Monitor logs. Most of the time, Azure Monitor Logs stores its data in what's called a Log Analytics workspace. There's a couple of choices, and I'll show you another choice in a moment, but you do need to turn this on per resource. Unlike the metrics, which are naturally captured because you're using Microsoft's infrastructure in Azure, turning on Log Analytics for particular resources is an optional thing, and you might choose to do it or not. If you turn this on, it's typically done on what's called the diagnostic settings blade for the resource. Those are kept for up to 2 years, and they're queried with a special language called KQL, the Custo Query Language. Here you see an example of a KQL query. What it's doing is summarizing data from the event log or event logs that have been captured from various resources and giving you a count of events that have happened in 5-minute increments over the last half hour. So for your exam, you should be able to recognize a little bit about KQL. You could spend a whole class learning about KQL and how to write detailed queries. Luckily, the portal has some nice examples, so if you have access to the portal, you can easily run through some examples. And once you get the flavor of these queries, you'll get a sense of how to recognize what one is doing if you see a question like that on your exam. So as Azure Monitor is capturing data for log analytics, it's stored in log tables, and these log tables are what you issue your KQL queries against. So those again can come from logs of an OS or a platform service. Sometimes an OS has to have an agent installed. Platform resources do capture this data automatically, but as I said, compute resources might require this log analytics agent. So it's a separate thing you could install on a VM, Windows or Linux, if you choose to capture logs. The last thing I want to point out in here before we look at a few things in the portal are some of the destinations for this monitor data. This can be a little confusing just because there's a lot of places in the portal where you can see information about logs, and it feels like they're disconnected, but behind the scenes it's really the same information, just accessed different ways. So platform metrics, the metrics are the numeric telemetry data. Those are captured typically automatically, and they're stored in this thing called metrics in Azure Monitor. And you can use Metrics Explorer, which I've shown you already, and then metric alerts, which I'll talk about later. Platform metrics also capture diagnostic information, which is stored in logs. So typically that's a log analytics workspace. So the logs are not the numeric data, but the record of what happened over time. You can also generate alerts from those, or run even special workbooks that are scripts that you have written to process information on these logs, run queries, and so forth. I want to point out there's another destination that you can use, which is an Azure storage account. So it is possible for platform metrics and resource logs, and even the activity log, which I haven't mentioned yet, but I'll talk about momentarily, to store in an Azure storage account. This is good for archiving information. So Azure Storage Account is just a regular storage account you create, and you can indicate that you want any metrics or logs to also be stored in storage for archive. You can stream them to external sources. And then finally, there's an activity log, which is a separate log. I'll describe it in the next section. It's just a record of everything that's happened in Azure, both from the portal, from PowerShell and the CLI. Any changes that are made to Azure are captured in the activity log. So metrics and logs, I would say, are related. That information can be queried from KQL. Azure Storage is a different place, Event Hubs are a different place, and the activity log is a different place. So I know it's confusing. Let's see if we can pick apart a few of those details. So over in the portal, if I look at my web app, for example, scroll down to diagnostics, or monitoring rather. If I scroll down to monitoring, there's a diagnostic settings section. So many resources have this diagnostic settings section. And this is where you configure the diagnostics or the logs that you want to capture for this resource. So not the metrics, I would say, but the logs. So click this Add Diagnostic Setting. These are the available logs you can capture. So maybe the app service logs, maybe the console logs. And then notice your destination choices. Think back to the picture we saw. The picture here shows you can send it to Log Analytics, you can send it to Azure Storage or an Event Hub. So you can send it to Log Analytics, and you choose your Log Analytics workspace. You could archive it to a storage account, in which case you have to choose information like retention, identify your storage account, and so forth. You can stream it to an external source or send it to a third party. So most resources that have these diagnostic settings show the same thing. I'll show you another example. If I go look at my storage account, my storage account has a monitoring section, there are diagnostic settings. I can choose one of these. I can add a diagnostic setting. What can I capture about storage? Reads, writes, and deletes. Those are the three things I get to capture. So I can pick some of these I want to capture. I can send them to the same places. The last thing I want to bring out in this section is that there is a favorite on your portal monitor called Azure Monitor. And it's another way that you can get access to these metrics and logs. But this is across your entire tenant. So under metrics here, if you're going to design a graph, you first have to choose the resource. So I can expand this resource. And then I see my web app. I can select it. So now I've chosen a scope. I can pick a metric. And there's my graph again. I could add another metric from another resource. So on the main menu, the monitor blade or page shows you information across all your resources in Azure. Same with logs. We'll talk about the logs in the next section when we get into KQL. So the one thing I haven't mentioned yet is activity. It's also in the next section. But hopefully metrics and logs make a little bit more sense now. They're both collected. They have different uses and different reasons. And you can optionally configure them, particularly log-wise, for Azure platform or infrastructure resources. In the last section, I tried to give you a sense of Azure Monitor and how it captures metric and log data. In this section, let's talk about some of the tools that are built on top of that data. The activity log is the first. So the Azure activity log is just a running record of all the things that have been changed in Azure in your subscription or in your tenant. So it's an audit log of what happened and who made the change. They're kept for the last 90 days and visible on the activity log blade. You can find that blade just about everywhere in Azure in every resource. Here's my app service. There's an activity log for the app service. I can see a record of the things that have happened in this time span, the last 6 hours. I don't think there'll be anything in the last 6 hours for my web app. Let's go look at another resource. Here's VM1. VM1 also has an activity log. Shows the list of things that have happened on that VM. You can change the time span if you like. You can also track up the resource chain. So resources belong to a resource group. There's an activity log at the resource group level. There's also an activity log at the subscription level. So you can see activities sort of anywhere from any level of your resource hierarchy and easily be able to track down and troubleshoot issues. Okay, next up is how to use the Azure Monitor logs to do some querying. So you might be capturing all this data in Azure Monitor. What can you do with it? So KQL is the language that's used for this, and a KQL query starts with a table name. Table name is just one kind of data that you're capturing in the log. So events is one. That would capture things like VM system and application events, like an event log in Windows. And so notice operators in KQL are separated by the pipe delimiter, the vertical bar, and they do things like filter or further modify the query. This is a kind of a complicated query, but if you study a few of these, you'll get the sense of what's going on. So the events table, we want to filter with a where, and I want the name of the event to be start. So there needs to be, in each event record, there would be a property perhaps called name. Anytime it's equal to start, we're going to pull that event. And then this word project just lists a set of columns that we want to show in our output. So a name, city, session ID, and a start time column, which comes from timestamp data. There's a join here. This starts to sound a lot like a database query, right? But we're going to join back with the events table, picking up this time stop events. And for the stop events, we want to pick the timestamp again and call it stop time. Also pick up session ID here. And the join, we join on session ID. So what we're trying to do is combine, get columns from different event records, some columns when the event started, some columns when the event stopped. In the end, we project the full set of columns. You might be wondering what the output for this looks like. You would end up with these columns that are listed here on the last project. And then notice duration column is just stop time minus start time. So it gives you how long that operation took between the start event and the stop event. Another example, here's storm events. That's another table that you could capture in monitor logs. We've got a where here too, so we just make sure that there is a property called end location. We want to summarize a count. So in other words, we're going to count how many event records there are, but we're going to do it by location, end location. So we end up with multiple counts, one for each location. We only want the top 10, so we pull 10 of those records, and then in a really cool way, KQL has graphical capabilities as well, so I can render my output as a column chart. And here you see that column chart. Each column is one of the end locations. I'm showing the top 10, and the graph just gives me a really great visual, which helps me sort of picture the data and get a quick sense of the information I'm looking at. On your exam, you might see a couple of KQL queries. You can practice a bit more in the portal if you go to a resource. Let me go to my VM actually. Scroll down to logs. So this gets you started with some queries. If I go to availability in this category, I can do count heartbeats. So this counts all computer heartbeats in the last hour. If I want to, I could just run this query here, and it's pulled my data. So what to notice here? I'm looking at a table called heartbeat. That's just a heartbeat table that indicates the VM is up and running, and it reports in typically every minute. And so I'm looking at heartbeat data where the time generated is less than an hour, up to an hour ago. And I want to summarize this count by computer. So computer name. I have one VM. So notice my summary here shows I have one computer and there's 60, a count of 60 heartbeat records. So that makes sense because in the last hour, if one's generated every minute, then there should be 60 of them. So if I had multiple VMs running, I would see a row for each one with a count. So you can write queries in this tool. You can also just play with a few queries, use a couple that they give you, just so you get a sense of what some examples of KQL queries would look like. The next tool I'd like to talk about is Azure Alerts. So Azure Alerts are things you can set up in Azure to be notified when something happens, when some resource, let's say, gets out of whack or has a bad value. They're typically based on resource metrics. There's several elements to setting up an alert. So let me talk about those, then I'll create one. So you'll first identify a scope. So the scope is the resource that you want to be alerted about. The condition defines the trigger for the alert. So you typically choose the metric you want to watch and then specify the threshold. If something gets above a certain value or under a certain value, then that would trigger the alert. The action indicates the response to the trigger. So actions could be like send an email, send a text message, call a script in a runbook. You can define groups of actions as well and then use them across several alerts. The last thing you define is the details. So it's what information you want to pass in the action. If it's an email or text, it could be just information about what resource is out of whack and the time the alert was generated and so forth. Let me show you how to set one of these up. So I'm in the portal, I'm looking at my app service. I'm going to scroll down again to the monitoring section, and here's alerts. Most resources have an alert section where you can define alerts for the resource. I'm going to create a new alert. So my scope is already chosen because I'm looking at my web app, so I've already chosen that resource. I need to define a condition. So the condition, these are the metrics that are captured. I want to use the HTTP server error message. Like my server is sending 500 errors. So to finish defining this condition, the portal shows me the aggregate of that value over the last 6 hours. I can change that if I want, but this is just to give me an idea of whether my signal logic is going to determine that this condition is going to fire. Keep scrolling down in this and you can, what needs to be filled out is down here at the bottom. So the logic for the alert is if the value is greater than some total value of, let's say 5 count over the last 5 minutes, evaluating every minute, then that's going to trigger the condition. So what I've said is if the total HTTP server errors is greater than 5, then trigger this alert. Next, I define an action. So I have to set up what's called an action group. Action groups can be reused across actions. I'm going to create an action group. It's a special resource. We'll call it web errors. You can have a group name and a display name if you want to get detailed about it. And then your notification type. So one of the things you might do is email someone in a certain role in Azure, or just send a general email. So if I say the name of this is email admin, I'm going to specify an email address here. You could also additionally send a text message. You could send a push notification to the Azure app on somebody's phone. You could have a voice call sent. Click OK here. There's my action group. I'm going to review and create that group. Now I've defined my scope. I have my condition. I've created action groups. There's the action group that I'm using for this alert. The last thing I do is specify the alert rule details. So this would be in the body of the email or the text message. You can set a severity. Maybe we'll call that critical. Create the alert rule. So now this alert is active. Azure will notify me if this metric ever gets out of whack. So just remember about alert rules. You need a scope defined, which is the resource, the condition, which is when it triggers, the action, what you want to do, and then just the details of what data is passed across in the action. Okay, the next tool that's built on top of the Azure Monitor data is Azure Advisor. So this is just a tool you can use in the portal. It shows you recommendations for optimizing your deployment. You can see here it uses categories like high availability category, security, cost, and Azure will just look at information about your subscription and resources, analyze it, and then provide you that information, and you can act on it if you choose. Some Azure Advisor recommendations even have a one-click fix you can do in the portal. So I can go, best place to find Azure Advisor is on the favorites on the left. Here's Advisor. So you can see for my environment, we have security recommendations and reliability recommendations. If I click on security recommendations, I see endpoint protection installed on a VM, installing Microsoft Defender for Key Vault, Microsoft Defender for DNS. I've got a Key Vault, so let me click through on this one. As I said, some of these have remediation, so I can find the unhealthy resource, select it here. If I click Fix, Azure will run a script that will turn on or enable Microsoft Defender for my Key Vault. So Azure Advisor is a great way, doesn't cost any additional money for the information we're seeing here, that can just provide you ways to make your environment more secure and run more smoothly. The next tool is Security Center. So this is similar to what we saw in Azure Advisor under the security category. It shows recommendations for improving your security posture. Provides a view of security of all your resources, and then generates a score. It continuously monitors new and existing resources. And then this score, this overall score that you see, just gives you an idea of, how on target you might be. Sometimes there are things in Security Center you don't want to change, or that are a problem and you're going to fix them, or they're temporary resources. So you're not required to make any of these changes, but information about them doesn't hurt. Related to Security Center is what's called Azure Defender. So this has additional protections over Security Center. It takes more of a defensive security posture for Azure, and also you can install it and set it up for on-prem resources. Continuously assesses resources, looks for recommendations, and then the Defender piece means it can take a more proactive stance in protecting your resources. Be aware that Microsoft is in the process of rebranding these tools. So Security Center and Azure Defender are being rebranded as Microsoft Defender for Cloud. On your exam, you might see either terminology. It's simply a rename. It doesn't really change the functionality. It's just they've kind of combined Security Center and Azure Defender. They've renamed it. And then Security Center is the free portion. Azure Defender is the one you pay extra for. I'll show you in the portal. So on my main menu, you can already see the rebranding here, Microsoft Defender for Cloud. I get a secure score. I can see some information about recommendations, things that are out of whack. You can interface with some other resources in Azure that deal with security, like there's Firewall Manager again. If you need to follow some regulatory compliance, you can see some information about that here. So they're just capturing all this under one place and trying to simplify the management of these resources. The last thing I want to discuss is application insights. So this is a feature of Azure Monitor that lets you track live applications. So as your apps are running in Azure, application insights can capture information about them, and then you can work with that information. For example, alerts are available for App Insights. You can also just generate reports that might be consumed by a visualization tool like Power BI. You can even look at live problems in applications, sometimes trace the problems in production. You can analyze response times and failure rates for your applications. If your application generates an exception, you can actually follow the stack trace on the live application to see what's going on. It's a very powerful set of tools. You can find application insights typically under workloads where you're running your code. So that could be a VM where you've deployed an IIS application. It could be an Azure web app. Let me show you in my Azure web app. I have my best app TRH. So there's several graphs and tools you can use in this application insights. My application is a little bit uninteresting. I will show you what some of these graphs might look like. You might need to identify which one would be appropriate for an exam question. So one of the things is called an application map. You can view a map of how your app components connect to each other. You can see average response times and look for bottlenecks. So here you can see a production app that's calling out to Azure Storage, calling to a SQL database, calling to another Azure Storage account. And you can see average latencies. You can see where bottlenecks might be. So application map can be a really powerful visual way to see what's going on in your application. Profiler is a tool that you can use to trace performance of a request to find slow code paths. It captures data without affecting throughput in the application, so it doesn't really slow down your application because most of the data it captures is captured on a back thread and asynchronously written into App Insights. But you can see a graph here of response times over time. Really neat way to be able to manage that. Next up for App Insights is the live metrics stream. So you can view requests and responses in near real time in the application and generate live graphs of what's going on for requests, for responses, CPU percentage, and things like that. Usage analysis allows you to explore demographics and statistics. So you can see here, this particular chart is showing you usage by location, Washington, Des Moines, and Chicago, so you can see where users are coming from that are using your application. Well, that's a wrap on the material for this course for exam AZ-104 Microsoft Azure Administrator. I'd like to personally thank you for joining me on this journey as we explored some of the services available in Azure. Remember, while Azure has hundreds of services you can deploy, you don't need to know all of them for your exam. You just need to know the services that are covered on the exam, all of which were discussed in this course. As you prepare for your exam, continue practicing with Azure and review relevant lessons in this course until you feel you are ready. Finally, here are a few web links that might be helpful. Check out microsoft.com/learn for more resources about Azure. docs.microsoft.com/Azure is the official documentation site about Azure and is a great place to delve into more details on any Azure service. Best of luck on your exam. I know you can do it.